Hi, everyone. Thanks for joining. Good evening. Welcome to the 2024 Best Robotics Simulink Summer Workshops. This is our first session today. My name is Tanya Kuravilla, and I work for the MathWorks. I work in the student programs team, and we support a bunch of competitions starting from middle school, high school, all the way up to university. And Best Robotics is one of the competitions that I support, and we try to do the Simulink summer workshops every summer just before the season starts to help teams get started with our software. So with that, let's get started. Just some basic housekeeping. We're already recording this, and we're going to be sending you a recording to this session. So please make sure that your mic is muted during the webinar. And if you've got any questions, please feel free to put it in the chat. And I will take breaks periodically to be able to answer all of those questions. Just a quick thing to note, please make sure that you register for each session. So this is session 1 that we're doing today, Wednesday, August 7th. And the reason we ask you to register for each session is so that we can send you all the materials and the resources tomorrow. So that would be the recording, the files, and all of that. So you'd have access to all of that if you just register, and we'd have you in our system to be able to just send those things out to you. Something important to note is that session 2, 3, and 4 are going to be on Thursdays. So today we're having it on a Wednesday, but the next 3 sessions are going to be on a Thursday, August 15th, August 22nd, and August 29th, respectively, and at the same time. So that's 7 p.m. Central Time. And make sure you register for each of those sessions as well. You should have gotten emails. If not, let us know in the chat, and we can put the link to all of the things where you can register. So this is our agenda for today. Before we get started, I'm going to show you how you can request license. We're going to be installing some files, that's called Robotics Playground files. And in today's session, we're basically going to get started with using MATLAB, and we're going to be looking at some basic robot movements. A quick reminder that all 4 sessions, each session builds on the other. So make sure you attend all sessions, or at least watch the recording to be able to follow the next session that comes up. And in each session, we're going to be covering very specific things. Like today, we're going to be doing MATLAB. In session 2, we're going to be doing Simulink, which is what most teams use. Session 3, we're going to be looking at state flow, which is another part of it. And in session 4, we're going to be looking at hardware and how you can deploy all of this to your hardware. Just a quick reminder, I think some of you are not muted, so please make sure that you are. And I think we're ready to get started. So let's start with this. So this is where you can request software. So if you go to your web browser and you say MathWorks Best Robotics, you should find a link. If not, I'm going to quickly put this in the chat for anybody who wants to request license. So once you get to this page has got a section that is called complementary software. So go ahead, click on that, click request software, and then there's going to be a software request form that comes up. Make sure you click on that, and that's how you're going to get access to complimentary MATLAB and Simulink license. And this license is going to be valid for an entire year. So basically your team can use it to prep and all throughout the competition season. So I've put that in the chat for anybody who hasn't been able to get access yet. And once you request license, it's probably going to take about 2 or 3 days for it to be processed. And you will get an email, with instructions on how to install and get started with the software. But please do, it generally gets done in a day, but give it 2 to 3 days so that you can get your license and get started. With that, I guess once you request your license and you've got access to software, the next thing that you can do is go to MATLAB. So this is the MATLAB environment for anybody who has not used it before. We have a bunch of tabs on the top. And the first thing that I'm going to show you is how to get access to the files that we're going to be using for these sessions. And for that, once you open out your MATLAB, make sure you're on the Home tab. And I just want to add that it's completely okay if you don't have access to the software right now. You can just watch and kind of grasp and understand the things that I'm showing you. Once you have access, you will also have the recording so you can follow along and do things at a later stage. So under the Home tab, you also have this button that's called Add-ons. So if you go ahead and click on add-ons, you have an option that says get add-ons. So go ahead and click on that. And that's going to open out a window that's called the Add-on Explorer. And at the top right, you should be able to find a search bar. And over there, go ahead and write out Robotics Playground. And hit enter. And once you do that, you will find this option for Robotics Playground. So go ahead, click on that. And now I have already installed this. So it says installed for me. But if you haven't installed it, then over here, you're going to get an option that says install. So you're going to obviously click on that, and that's going to install for you. So make sure you do that, and that's how you're going to get access to the files that we're going to be using. So now once you've done that from the Add-ons Explorer, once you've installed your Robotics Playground, there's a tab at the top, which is called the Apps tab. So when you click on the Apps tab, you will find that there is a drop-down, and you should be able to find the apps that you install under My Apps. And you have the option, there's a star at the right corner, upper right corner, and you can go ahead and you can click on that. And so you can make that your favorite. So you'll find that right at the top. So here is the Robotics Playground app. I am going to go ahead and I'm going to click on that. And that opens out the Robotics Playground app. And over here, you're going to find a button that says Lessons. And when you click on, I'm just going to pause for a real quick minute because I see that most people are saying that there is no audio. Can people confirm?
I have audio.
Tanya, we can hear you very loud and clear.
Okay, so
I have audio on mine.
okay, great. So
I have audio.
okay, awesome.
I'll get on chat and follow up with these.
Okay, perfect. Great. Thanks so much, everyone. Maybe try to rejoin if you don't have audio, but okay. Great. Thanks for the confirmation, everyone. So once you click out Lessons from the Robotics Playground app, you will find that there are a bunch of lessons that pop up here. So you'll find Unit 1 to Unit 9. And these are the lessons that we're going to be using through these sessions. Let me just go ahead. And there are no questions right now, so we'll just get started then. So like I mentioned before, once you've got all your lessons, once you've got your license and all your lessons, this is the first thing that you see, right? When you open out your MATLAB, this is the MATLAB environment. And here you will find a bunch of different things. So first thing here is right at the top, you will find a tool strip. This is where there's a bunch of tabs. You'll find that there's a bunch of buttons, some of which we're going to use. We already used the add-ons button here to get access to the files. But this is where you will find a bunch of buttons that you're going to use as you're using the software. And here you also have the current folder. And in the current folder section, you're going to be able to find all your files. So all the files that you use are going to pop up here. Then you've got the command window here in the middle. And this is where you type out all of your commands. And at the bottom here, I have the workspace. So the workspace is where any variables that you use in your programs, that's where it's going to pop up. That's where it's going to show up. That's the workspace. Now, for some of you, if this is not how your interface looks, that is probably because you have a different layout. So again, under the Home tab, there is a button here that's called Layout. So if you click on Layout, there are different layouts that you can use. This is the default layout that I just showed you. There's also the 3-column layout, which basically brings the workspace to your right. And the other thing that you can do is you can customize the way that your interface looks. Like under current folder, there is a downward arrow. If you click on that, you can minimize, you can maximize, you can undock if you want to. And once you do any of this, if you minimize, you maximize, or you undock and you don't know where to find your workspace or your current folder, all you have to do is go back to layout and hit default or 3-column based on your preference, and it'll all pop up again. So that's a pretty important thing to note. We sometimes have teams reach out when they don't know where their workspace or their current folder is. Just go back, go to the Home tab, go to Layout, and hit Default. So once you've done that, let's look at how you can... Was that a question? Sorry, I didn't hear you. If you've got any questions, feel free to put in the chat. Happy to answer them. Okay, so obviously you can tell MATLAB what you want it to do, and it's going to do it for you, and you can run commands, and you can type the command you want, and you can execute it in the command line. So basically, if you want to say add 2 numbers, you can add 2 plus 3, and if I hit enter, I'm going to be able to see the answer, which is 5. So basically, there is a variable that gets created to store the answer as ANS and the value 5. And as soon as I run this command, you'll also see in your workspace that ANS with the value equal to 5 gets created. So workspace is where all your commands and everything gets stored. You can also create your own variables. So if you want to create your variable, say my value is equal to, let's say 7. And if I hit enter, you'll see that in the workspace, there's also a variable that's created with the name my value and value equal to 7. So now, if your command window gets crowded, or sometimes you just don't want to see the output. And if it gets too crowded with many answers, all you have to do is you can just put a semicolon at the end of the line, and that suppresses the output. So if I say, if I create a variable c is equal to 8 plus 3, and I use a semicolon at the end of that line, and I hit enter, you will see that I don't see the answer in my command window because I've suppressed the output by adding a semicolon at the end. But in the workspace, you will see that your variable c with the value 11 is still created. So it's sometimes useful when there's a lot of lines of code, or you just want to suppress some outputs. It's not really required. You can feel free to just use a semicolon at the end of the line. So now, once we know all of this, the next thing that we will look at is how we can clear this workspace, right? So now we've created a bunch of variables, and if we just want to like clear everything, delete all the variables in the memory, all you have to do is type out clear in the command window and hit enter. And you now see that your workspace has been cleared of all the variables. And similarly, you can also clean out your command window. And to do that, you can just type out CLC and hit enter, and that's going to clean out your command window. So now that we've seen how you can run your commands using the command window, it is very useful. But when you have many lines of code, it's more useful to be able to do it using a MATLAB script. So MATLAB scripts are basically MATLAB files that contain a program, and scripts basically just contain multiple commands. The command window makes it hard to have very long lines of code, and so that's why you would use a script. So again, in the tool strip under the Home tab, you'll find that there's a button that's called New Script. So if you go ahead and click on that, that's going to open up this editor. So this is the editor that you get, and you can save these MATLAB scripts, and you can type commands here in the order that you want them to be executed. So let's write out some lines of code. Let's say result 1 is equal to 7 plus 1. I'm going to suppress the output, so I'm just going to put a semicolon at the end of the line. I'm going to say result 2 is equal to 6, put a semicolon at the end of the line. Result 3 is equal to result 1 plus result 2. I'm not going to put a semicolon at the end of this line. So once you've done that, you've written out your code. The next thing that you can do is you can hit the save button that pops up here. Once you open a new live script, once you open out a new script, you will see that there is also a tab here that's called editor that pops up. And under here, you'll be able to find the save button. So if you hit save, it's going to basically pop up this window where you can save it, and you can go ahead and call it whatever you want. So I can call it, say, maybe my first script. And you'll see that it all gets automatically saved as .m files. That's the .m extension that it gets saved with. So go ahead and hit save, and that's how you create your first MATLAB script and you save it. Now, once you've done that, the next thing that you're obviously going to do is you want to be able to run this MATLAB script, right? And to do that, again, under the editor tab, you will find that there is this button, the green play button, and it's basically the run button. And it's basically used to run MATLAB scripts. So go ahead and hit the run button. And when you hit the run button, you will see that in the command window, you see your result. Result 3 is equal to 14. And the reason that you see it in the command window is because I didn't add a semicolon at the end of result 3. But if you look in the workspace, you'll see that you have 3 variables that are created, result 1, 2, and 3, with their respective values. So that is how you create your first script, save it, and then you can run it. So scripts are useful when you have many lines of code, and when you want to program, you would use a script. So let's try to write another MATLAB script. And to do that, you can either press this button here, plus the addition or the plus button here, and that's going to open out a new script for you. Or you can, there is a button here under the editor tab that says new, there's a drop down, and you can select script, and that's going to open out a script for you as well. So you have 2 ways of doing that. So let's try to calculate the length of the hypotenuse of a right triangle. And to do that, let's go ahead, open this out. Let's just quickly look at the formula. So this is what we're trying to do. We're going to try to calculate the length of the hypotenuse of a right triangle. So we're going to try to find the length of C, and we know that this is the formula, or this is the equation where C is equal to the square root of A square plus B square. So this is what we're going to try to do right now. So now that we've opened out our script, let's go ahead and write the code for it. I am going to say A is equal to 12, B is equal to 17. So those are the 2 sides of my triangle, and I'm going to try to find the length of the hypotenuse. So I know that C is the square root of A square plus B square. So once I've done this, I'm going to go ahead and I'm going to save it again. I'm going to call it maybe hypotenuse. Maybe. So once you've named your script, MATLAB is pretty smart because there is a function, a built-in function in MATLAB that is called hypotenuse. It basically calculates the same thing. It's hypot. So it's warning me and it's saying that there is already a built-in function. So to avoid a conflict, maybe change the name. So MATLAB does give you, it warns you, it gives you errors and all of that. So it kind of tells you we suggest that you rename the function to avoid a conflict. And the way that you can rename is by right-clicking, and there's an option to rename. So you can maybe call it, I'll probably call it hypotenuse, and then that automatically just changes for me. So once I've done that and I've written out my program, the next thing I'm going to do is obviously hit the green run button. And once I do that, I will be able to see that my hypotenuse or my result has been calculated. So C is equal to 20.8087, which is the hypotenuse of a triangle with sides 12 and 17. And again, when you look at the workspace, you'll see that your variables A, B, and C have been created, and it's storing all of their respective values. So this is how you can use scripts to write out your program and to do things in MATLAB. Now, the next thing that we're going to look at is we're going to be looking at how we can create MATLAB functions. And creating MATLAB functions is important because just like you saw here, we use a function, sqrt, which is basically an algorithm that helped us calculate the square root, right? It's a built-in function. we also would sometimes want to be able to create our own functions and reuse them within our code. And the reason that functions are helpful is because it helps execute previously written code with one command. And the way that you can do that is you can, under the editor tab, there's a new button. So when you click at the drop down, there is an option called function. So if you go ahead and click on that, that's going to open out this template for you. It's going to open out a function template for you where you've basically got the function, you've got your output arguments and input arguments. So the difference between a MATLAB function and script is that functions basically take input variables and return output variables to the program that's calling it. So once you've got your template, you can go ahead and make changes to this. So again, let's stick to calculating the hypotenuse. And for every function ends with a keyword, which is basically called end. So it starts with function, and the ending of the function is with the word end. So let's go ahead and modify this template for us. And we're trying to find the hypotenuse. So let's go ahead and do that. So the first thing that I'm going to do is I'm going to change the name of the function from untitled 5. I'm going to change it to calculate hypotenuse. So once I've changed the function name, the next thing that I am going to do is I am going to change the input and the output. So for the input, I know my inputs are sides of the triangle. So that's A and B. And my output is basically going to be C. That's the length of the hypotenuse. And once you've done that, the next thing that you can do is you can go ahead and you can just copy out this line of code. So I'm going to copy this, and I am going to just paste it here. And all that's basically doing is it's basically the formula for calculating the hypotenuse. I'm going to go ahead and I'm going to clear my workspace. I'm going to clear my command window as well. It's getting a little too crowded for me. I like it clean. So you can use your clear and CLC commands to do that. So once you've done that, go ahead and save your function. So when you hit save, you will see that the file name is going to be the function name, and that's very important for your function to be able to work. So don't go ahead and change that because this is basically the same as the function name. So go ahead and leave it as is and just hit save. So now that we've written out our function and we have created and saved our function, let's go ahead and call the MATLAB function. So I'm going to do it in the command line. I'm going to call the function. So I'm going to say calculate hypotenuse. That is the name of the function. And I'm going to give it the inputs, right? So let's say the sides of my triangle are, one side is 4 and the other side is, say, 5. And then I will hit enter. And then you will see that you see your answer here, which is 6.4031. So that's how you can create MATLAB functions. Now, another thing that you can do is you see that there are green lines of code here. And the reason why these lines of code are green is because they are comments in your code. And the way that you identify them is, one, obviously they're green. And the way that you can turn a line in a script green is by using this % symbol at the beginning. So when you use the % symbol, you can add a comment. And any character to the right of this symbol on that single line will not be executed when the script or the function is basically run. And this is helpful because comments are very important when you're programming. When you share your code, or for anybody who's looking at your code, it's important to understand what is going on. And these programs are relatively simple. It's just got a line or two of code, and so it's not very hard. But typically, a program would have multiple lines of code, and having comments are very important. So if you just want to comment your code, just use the % symbol, and then you can probably just give it a description. You can say this function calculates the hypotenuse. And of course, you can maybe give it more explanation. And you can say calculates the hypotenuse given the length of two sides of a right triangle, and so on. So you can make it as descriptive as you want, but basically using the comment, the % symbol helps you create a comment. So that's how you comment your code. And another good thing with MATLAB is that it's got documentation, which is pretty detailed. And the way that you can access that is by hitting DOC doc in the command window. And if you hit enter, that's going to open out the MATLAB documentation. And you can then, there's a search button here, and you can basically search for any functionality that you want to find. So say you want to look for plot, you can say plot, and you hit enter. It's going to give you a bunch of options, and then you can choose whichever makes sense for you. Click on plot, it's going to open out that documentation page for plot. It's going to give you the syntax, it's going to give you a description, and it gives you an example. When you go down, there's a bunch of examples to create a line plot, to plot multiple lines, plot from a matrix, and so on. And there's a button here that if you click, it's automatically going to open it out in MATLAB for you. So documentation is pretty cool for when you want to search for anything that you need help with. Now, that is documentation, and sometimes you're not sure what you want to use, so sometimes going through the documentation helps you kind of figure out what function you need. Now, if you're in a situation where you know what function you are using, but it's probably throwing you an error, and you basically want to understand, maybe you're making a syntax mistake, or you want to understand what it's doing, all you have to do is, again, in your command window, you can hit help, and you can say plot, and then when you hit enter, it's going to give you information about plot. And now similarly, you can do that for anything. So now you can say help, and we were looking at, we use the square root function, so you can say sqrt. And if I hit enter, it's going to give me information about the square root function, and then it'll give you links to be able to click to the documentation and so on. So if that line of code is throwing an error, I know what I can do in the command window. Just something to note is that sometimes when you hit doc, it might pop an error for you, and that's because documentation has not been installed. And to do that, you just have to go to the Home tab. And under the Home tab, there is a button here next to Layout that's called Preferences. And if you click on that, you will find Help to your left. And then it says Documentation Location, and you can basically go ahead and just install that. So if it does throw an error for you, just make sure you do that, and that should fix it. And that's only because MATLAB doesn't automatically install documentation for you right now, for those of you who have space concerns. So it's just something that's optional, so you can go ahead and just install that yourself. So that was just a quick introduction to MATLAB, how to create, how to use the interface, how to navigate through the environment, how to create a script, how to do other things as well. And something that I want to quickly call out is there's some next to the new script, there's also something that's called new live script. So if you click on new live script, the first difference that you will see is that you will see that all your scripts had a .m extension and live script has a .mlx extension. And basically a live script is basically just more of an interactive document, and it just gives you a bunch of more options. So now you'll have a live editor tab that pops up when you open a live script. And what this basically allows you to do is basically also include some things like text. So you can say my first live script, and you have the option to maybe make that the title, to center align it. And then you can say, this is my first live script again. So basically, you can have an explanation. You can include some text. Then you can, again, there's a code button here. So you can insert code. You can say A is equal to 4, B is equal to 3, C is equal to A times B, and so on. And then again, you can add text again. The other thing that you can do is there's a button here that's called insert. So if you click on that, you'll be able to add things like equations, LaTeX equations. You can hyperlink things. You can add images. So if you click on image, it'll take you, and if you've got any kind of image on your computer, you can go ahead and you can attach it there. And this is also really used for documentation. It can be used when you're trying to document stuff. And once you've got your live script, you can add your images, you can add GIFs, you can add your code and all of that. There's a button here that says export. If you drop down to that, you can export it to PDF, to a Word, HTML, LaTeX, and so on. So it's also used a lot for documentation. So that is the difference basically between a script and a live script. And yeah, like it's mentioned in the chat, this is a great option for the engineering notebook. You can use this to include your code, images, and so on. And some cool things that you can do is, you can have headings, different kinds of headings. And then towards the end, once you're done with your live script, if you just click on table of contents, it'll get automatically generated from you. It's going to pick out all the headings, and all of that can be done. You can add equations, hyperlink things, you can add tables, and all of that. So something worth noting. I am watching the chat. I don't think there are any questions. But if you have any questions, feel free to put in the chat and we can tackle that. I'm going to go ahead and I'm going to close out the rest and we can keep going. Okay, so now that we're done with that, another thing to note is what we just covered was Unit 1 from the Robotics Playground. So if you click on Unit 1, there are a bunch of exercises. So that was calculating the hypotenuse. So you will find all of those scripts included in the exercises folder. And there is also a PDF. So if you right-click on it and you hit open, it's going to basically open this out for you, right? So it's going to open out this for you. This is basically everything that we just covered. So this is a great way to just kind of recap everything that you did in that unit. So if you'd like to spend some time after this session or through the week, go ahead and open out this PDF and then follow along and you'll be able to do the exercises. It's basically everything that I just covered, but it's also available as a PDF. Quick question on what exactly is the difference between a script and a live script. So basically in a script, you can only have code. If you want to have text, you're going to have to use the % symbol and have comments. And in a live script is more interactive, so you can add text, you can add images, you can have code, you can automatically export that to a PDF, to Word, to LaTeX, HTML, and so on. So it's a great way for documentation. You can change the alignment, you can change the text, you can make a title, heading, and so on. So it's basically good for documentation, if that makes sense. Okay, and now once we're done with that, the next thing that we're going to do is let's move on to Unit 2, which is basic robot movements. So again, double click on that. Again, there's the PDF version of that is available, so you can right click and that's going to open that out, or and you can also find the exercises in this folder here. Okay, so we're going to be, this is all getting recorded and you're going to get access to it. So if you've joined late, you can just watch for now and we will send you a recording of this and we'll also send you the resources for the GitHub repo and so on. So now let's, so when you open out your Unit 2 under exercises, you'll find that there's a bunch of scripts. And most of these scripts, there is a start script and there is a solution script. So there's move forward underscore start, then there's move forward underscore solution. So I recommend you always get started with the start script. And this is because there's an option here for you to be able to do some work, to be able to code and try to figure it out. And if you get stuck, then you can use the solution script where everything is already filled out for you. So make sure you always get started with a start script. So now what we're going to do is we're going to be starting a virtual environment from MATLAB. And the Robotics Playground provides a MATLAB virtual environment for understanding how to program simple robot tasks, such as controlling the robot motion. And we're going to be using a simulator. And this simulator is called ML Robot. So just like I showed you before, if you go ahead and you hit help, and let's say you type out ML robot in your command window, we're going to get a summary of what it does. And it's basically says that ML robot creates a MATLAB disk robot in a virtual environment, and it's intended for learning to program in MATLAB using the robotics playground and so on. And then there's obviously some examples and some explanation that goes with it. So just in general, if you need help with anything, always make sure you just hit help and you can hit that function. So we're going to use the ML robot class to create a robot within a virtual environment, and we're going to assign it to a variable. So let's go ahead and do that. So let's say, let's create a variable, my robot. And I'm going to say ML robot. And I'm going to hit enter. Now, once I've done that, I'm going to start the virtual environment. To start the execution of the virtual environment, I'm going to use a function that's called ML robot start. So I am going to say ML robot start, and I'm going to say my robot. And again, you can see here that it's given you all of these options, right? It says ML robot start, ML robot stop, set motor voltage. These are all things that we're going to come through, but when you hit help and ML robot, it'll give you all of this information as well. So I'm going to start the execution of the virtual world by starting this. I'm going to go ahead and hit enter. And this is the window that of the environment that's going to pop up. So when you see the Mechanics Explorer, you basically see your environment, you see your robot as well. And one thing that you can do here is there are different views. So there's the front view. There are different views of how you can view this, or if you want to view it at an angle, which is probably best to do, you can do that. So this is basically the virtual environment that we're going to be using. So now we've got our environment and we've got our robot. Now, how do we make our robot move, right? Now, each wheel of the robot has a motor, and you can set the voltage of the left or the right motor by using this command that is called the ML robot set motor voltage. So let's go ahead and let's do that. So again, here in the command window, I'm just going to say ML robot set motor voltage. My robot. I'm trying to move the left wheel, and I'm going to give it a value of 3. And once I do that and I hit enter, you will see that your robot is now moving, right? Because you set the voltage in one of the motors, which is the left motor, you set it to 3. So now your robot is basically rotating in a circle. So now another thing that you can do is now if you want to make the robot stop, you can obviously say, I just hit the upward arrow so I can get my previously executed command. And I can change it from 3. If I go ahead and I change it to 0, you'll see that my robot stopped in my virtual environment. I just set the motor voltage of left from 3 to 0, so my robot has stopped moving. So my robot has stopped moving, but when you look at my virtual environment, you'll see that my simulation is still running, right? And you can see that here because in the right bottom corner here, you'll see that the time is still moving. So even though my robot is not moving, my virtual environment is still running. So if I want to stop the virtual environment, what I'm going to do is I'm going to go back to my command window. And to start it, we said ML robot start my robot. To stop, we're just going to do the opposite. So we're going to say ML robot stop my robot. And then it tells you that your simulation has stopped. And when you look at your Mechanics Explorer, you will also see that time has stopped here. It's not running anymore. It's stopped. And so we know that our simulation is also stopped. Now, another thing that you can do is you can hit help ML robot set motor voltage. And if I hit enter, it'll give me an explanation or a summary of what's going on, right? So it says it sets the motor voltage for either the left or the right motors connected to the wheel of the ML robot object. And it says motor selection is left or right, and the voltage range is between -5 to 5. And now I gave it a value of 3. That's how I knew what value to give it, because the range that you can provide to each motor is between -5 to 5, and that basically decides which direction and how fast the robot is moving. So once we're done with that, let's go ahead and open out move forward _ start. And basically all that we're trying to do here is we're going to get the robot to move forward for 5 seconds and then stop. So you'll see that some of this has already been pre-written for you. And all that we're doing here is ML robot, my robot is equal to ML robot. So we're creating the virtual robot. We're starting the virtual environment, ML robot start my robot. And then now we're going to we're going to write the commands to set the motor voltages. So let's go ahead and let's do that. And to do that, it gives you a hint here. It says use ML robot set motor voltage. So let's go ahead, let's do that. And we're basically writing out the same things that we wrote in the command window, but we're just writing it in a script. So I'm going to say my robot. I want to set the left one to a value of 3, and I'm going to copy that line of code, and I'm going to paste it, and I'm going to just do the same thing and change it to right. I can go ahead and add semicolons if I just want to suppress the output. And once this is done, I've also added a pause command here. There's a line that says pause for 5. It basically says you're delaying for 5 seconds so that the robot moves forward. So basically, these lines of code are executed for 5 seconds. And yeah, and then we've stopped the simulation. So let's go ahead and let's run this and see what happens. I'm going to go ahead, run it. I see that my robot is just moving in circles, and you'll see that the simulation stopped at time is equal to 5 over here. That's because I put the value pause 5. Right? So now my robot didn't move forward. It just kept rotating in a circle. And the reason for that is because I didn't invert the value of one of the voltages. So I'm going to go ahead and I'm going to do that. I'm going to make the right motor. I'm going to give it a value of -3. And once I do that and I hit run, I see that my robot is moving backward instead of moving forward, right? And that just means that I messed up the signs for my left and my right motor. So I'm just going to switch it up. I'm going to change right from -3. I'm going to just make that 3, and I'm going to give left a value of -3. And now when I hit run, I'll see that my robot is moving forward. And it's going to stop at time 5 because the code here says pause 5. And that basically means that these 2 lines of code gets executed for 5 seconds. Now, if you want to make the robot stop, all you have to do is you just have to set both the motor voltages left and right to 0. So I'm going to copy these lines of code, paste it here. I can change it to 0. And I can hit run. And it's basically going to just move forward, and it's going to pause at 5 seconds. Does anyone have any questions regarding this?
Yes, Tanya, there's a question in the chat. You're receiving an error. Execution of script ML robot start is not supported.
Okay, so I do see that it says that execution of script ML robot start is not supported. I'm not sure, but maybe we can debug towards the end. I would just go back to the Home tab, go to Add-ons, go to Manage Add-ons. Look for the Robotics Playground and make sure that it's installed.
Sometimes in the past, I've seen more than one robotics playground show up. Make sure you get the right one.
Right
One of them is a package, I think.
Right. So when you go to add-ons and you go to get add-ons and you look for robotics playground. There's a robotics playground and there's a robotics playground expansion pack. Make sure you're just installing the robotics playground by the MathWorks student competitions team. And then let us know, and then we can help you figure it out if it still is not working for you. So we basically just got our robot to move forward. Now we can do a bunch of things with this. No, there are no benefits. It's not something that you should worry about. The expansion pack is not something that you have to use for the competition. So just the regular robotics playground is good. I saw that pop up in the chat. So now the next thing that we're going to do is let's look at making our robot move forward and then back. And just for the sake of time, I'm going to go ahead and I'm going to open out the move forward and back solution script. Let's go ahead and open that out. And like I mentioned before, the solution script has basically got the answer. So you can open you should still start with the start script, try to figure it out, and then look at the solution script. But I'm just doing it to be mindful of time. So again, here, when you look at the script, we're doing all the same things. We're creating our virtual robot. We're starting the virtual environment. Here, we want the robot to move forward. So we're going to set the motor voltage for the left and the right, -3 and 3. It's going to be different because we want the robot to move forward. We have a delay for 5 seconds. So basically the robot, which means that the robot is going to move forward for 5 seconds. Then we want to make the robot turn because we want it to move forward and then come back. And to make the robot just rotate in its place, like we've seen before, you just have to give it the same value. So we're giving it both a voltage of -3, and we're going to make it rotate for a bit. And we've set pause for 6 seconds. So that basically means that the robot is going to rotate for about 6 seconds. And then the robot is then going to move forward again. And again, when the robot moves forward, you can see that I've set the motor voltage for the left and right to be opposing. So that's -3 and 3. And it's going to move forward again for 5 seconds. And then then we set the voltages to be 0, and then we stop the simulation. So let's go ahead and hit run. Let's see what happens. So the robot is moving forward for 5 seconds, and then the robot is rotating, turning for about 6 seconds, and then the robot continues to move forward for another 5 seconds, and then it stops. So you can do a bunch of things. Now, if you want to go back to the same location, you don't necessarily need to make the robot turn. You can make the robot go back to where it started by just making the robot move backwards. That is an option as well. So it's really up to you. You can just experiment, try out different things with your robot, change the voltage values. You can make it go faster or you can make it go slower. as you saw, the range was between -5 and 5. So you can play around with that. And if you need help with any of the functions, go to the command window, hit help, write the name of the function. It's going to give you more information about what the ranges are, what is happening, and so on. Right. So that was moving forward and then moving back. The next thing that we are going to look at is we're going to be looking at the robot's orientation. So it just basically trying to obtain information from the robot movements to understand its behavior and so on. So we're going to try to plot the robot's heading or the orientation with respect to the stationary world. So when you look at the robot, we're basically trying to get information from the compass that is located in the robot's center. And I'm basically doing that by just scrolling the middle wheel of the mouse. You can zoom in and you can zoom out. And to be able to get the robot orientation, we're going to be using a function that's called ML robot read compass angle. And if you want to, again, understand more about this function, like always, go ahead, hit help, ML robot read compass angle. And then it's going to give you an explanation here. So it says it basically reads the angle an ML robot robot with respect to the world in degrees. And then it gives you an example. So let's go ahead and open out the plot orientation underscore start script. And let's look at this now. And so here again, we're doing the same things. We're creating a virtual robot. My robot is ML robot. We're going to start the virtual environment in simulation, ML robot start. And then you will see that there is a for loop over here. There are some things that have been done for you, but there are some things that you're going to have to complete. So we have a for loop here. A for loop is basically a programming concept that helps you execute code multiple times. And here it's going from 1 to 30. So you'll see here that we're using ML robot set motor voltage. So we're setting the left and the right motor to a value of 5. So it's at its maximum value of 5. And we're also setting the left and the right motor to be the same value, right? They're not, one is not negative and the other positive. They're both positive in this case, which basically means that the robot is going to just rotate in its position and go in circles. So once we've done that, it gives you prompts, the starter scripts. It tells you to assign the output of ML robot read compass angle to a variable named angle. So let's go ahead and do that. So I'm gonna use this, put that there, and I'm going to say my robot. So there are comments here which tell you what to do with, which prompt you on how to code and what your next line is going to be. So you can go ahead and you can do that. And then there's a pause for 0.1 seconds before reading the next robot angle, and then you're ending the for loop. So basically what we're trying to do here is we have a for loop which goes from 1 to 30. The robot is rotating in its place. We're reading the robot angles and we're waiting for 0.1 seconds. So we're trying to take 30 measurements and wait 0.1 seconds, which means we're going to take about 10 measurements per second. So now if I just go ahead and if I run this, I see that my robot is just rotating. I'm going to go back here. And when I go back here, you'll see that there is an angle here, right? So you see that here, it's basically, it's been running a bunch of times, but let's look at the last time. So the value of angle here, you can see goes from 0, 0.0, 3.1, all the way to 136.36. Let's go ahead and fill this out a little bit more. And now that we have our different angle values, so we've basically tried to get the orientation of the robot with respect to the stationary world from the compass that's located in the robot center. The next thing that we're going to do is let's try to visualize it, right? It's much easier for us to be able to visualize these angle values that we saw in the command window in the form of a plot. And to do that, the first thing that we're going to do is when we're going to plot the angles that we just saw in the command window here, all of these angle values, we want to plot it with respect to time, right? So we can see it in the plot. And to do that, we're creating a time array here where time is equal to 0.1 to 3. And what we're trying to do here is we are recording time for 3 seconds. So basically it's going from 0.1, it's going all the way up to 3, and it's happening in intervals of 0.1 as well. So that basically means that it's 0.1, 0.2, 0.3, 0.4, all the way up to 3 seconds. And so we're just creating this time array so that we're able to plot it with the angles. And an array is basically something that you use in programming to store multiple values. And the reason that we're creating here again is to just be able to plot it. So now let's go ahead and plot. It says use the plot command to plot the robot angle versus time. Now, to be able to plot, I'm going to make sure I take off this percent sign in front of plot, and that way it's going to get executed when I hit plot. And to plot on the x-axis, I obviously want time. And on the y-axis, I want angle. So MATLAB is pretty smart. It's kind of auto-completing it for me. So if I just hit tab, you'll see that it gets filled in by itself. Another thing that you can do is you can highlight, right-click, and you can just evaluate that selection in the command window. So if I just evaluate that part, you see that it pops up in the command window, right? And again, in my workspace, I see that there is something that's called time. And if I just double-click on that, you will see that this is the variable time, and it's basically got values 0.1, 0.2, 0.3, all the way up to 3. And it's got about 30 values, right? So it's a 1 cross 30 array. And similarly, now that we've got the plot command, go ahead, you can just right click and you can say evaluate selection, and you can see that your plot comes up. So basically, when you look at this plot, this might not make a lot of sense because we've not labeled our axis. And it's always important when you create a plot to be able to label your axis and to give it a title so people know what they are looking at. So let's go ahead and let's do that. So there are some lines of code that's been written here. Let's go ahead and take off the comment and code and write out some code there. So for the title, let's say it's robot orientation versus time. And on the x-axis, I know that it is time. and that is in seconds. And on the y-axis, I've got robot orientation. And this is in degrees. Once I've done that, I'm just going to run. And then my plot comes up again. And this time with the title, with the x-axis, and with the y-axis all labeled. And I know that I can see the values, my orientation values for my robot. So you can see that for x value of 3, y value of 136.627. And all of this is coming from the values of the angle that were generated, right? So this was what was generated. So 136.622 was the last value. When you see all of that basically got plotted. And I mean, those were just some of the concepts that I wanted to show you today. So basically, it was to show you how you can use the robotics playground virtual environment to get started with programming your robot, how you can set the motor speeds to achieve a certain robot motion, and how you can collect and analyze data from the robot movement like we just saw here, right? We had the orientation, we just try to plot it versus time. So you can, it's just a quick and a small example of how you can collect and analyze data from your robot. So that really brings us to the end of Unit 2. Again, each unit has got a PDF. So go ahead and open that out, and it's basically got everything that we covered today. So that's going to help you recap if you're lost with any of these concepts. And another quick thing that I'd like to show you is, so we made the robot move forward, we made the robot move forward and backward as well. We've got a quick assignment for you for next week, for you to just practice through the week, and that is for you to get the robot to navigate in a square pattern. So basically move forward, turn 90 degrees, move forward, turn 90 degrees, move forward, and turn 90 degrees until it forms a square. And feel free to try this out. And you can also create a video if you want to share. So if you go to your Mechanics Explorer, and if you go to Tools, there is a option that says Video Creator. So you can create a video of your simulation. And if you want to share it with your friends, if you want to share it with us, you can feel free to create a video and you can send it to us. So that's a quick assignment for those of you who want to try it. We encourage you to try it because there are new things that you learn, new things that you'll figure out, apart from the things that I showed you today. But just to recap, you can please make sure you get your license, install it. You can install the Robotics Playground from the Add-ons Explorer. We will also send you the link to the GitHub if you want to download it from there. If you have any installation issues when you're getting your software, we're going to send you the technical support information. If you've got any other questions related to what we showed you today, that's not installation related. So basically, if your robotics playground is not working, or if you have a question related to something that we discussed today, you can just send us an email to roboticsarena@mathworks.com. If you want to share your video with us of your robot navigating the square, again, write to Robotics Arena. And from your robotics playground, make sure you follow lesson plans for Unit 1 and Unit 2. And make sure you follow the PDFs. So this was the first session. We just want to introduce you to MATLAB and how you can start off with some basic robot movements. Next week is going to be slightly more packed. We're going to do Simulink, which is what most of you are going to be using to program your best robots. So we'll have a lot more, but definitely learning a bit about MATLAB and understanding how to get started with the robotics playground is foundation for what we're going to do next week. And now you can see that your robot moves forward, turns 90 degrees, moves forward again, and it'll keep doing that until it makes a square pattern and comes back to where it started. So the robot is now back to where it started. It just navigated a square pattern. So again, like I mentioned, this is one way that you can do it using the for loop. If you don't want to use a loop, you can copy and paste these lines of code 4 times, or you can come up with other ways to do it. And if you guys have any fun or different ways that you tried it, feel free to let us know, and we can share it with everyone else. So again, sometimes one thing to remember is that your MATLAB may hang, especially if you've had it open for, let's say, more than a couple of weeks, like I did, or if you've got a bunch of things open, or you've been using it a lot. If you run into issues where you think that things are hanging, or like the Mechanics Explorer wasn't really, it popped up, but we couldn't really see the robot, just go ahead, close it down, and just open it again, and it should work. So that was our assignment from last week. So let's go ahead and I'm going to open out my robotics playground and go back to my lessons. And again, for the robotic, to get the lessons from the robotics playground, just go to apps, and under apps, if you've already installed it, you will find the robotics playground app. You can favorite it. So go ahead, click on that and click on the lessons. And that's going to pop up all these lessons for you. So the next thing that we're going to do is we're going to be looking at Unit 3, which is Intro to Simulink. Unit 1 and 2 is what we covered last session. So let's go ahead, double click on that. And like I mentioned, there is a PDF associated to each unit. So go ahead and open that out. I already have that open. So let's look at that real quick. So today we're going to be looking at Simulink. Simulink is a graphical modeling environment. It's the environment where you put your models. It's used for both simulations and for software deployment by engineers and scientists. And in this case, for B.E.S.T, you're going to be doing simulations like we're doing right now. And then you're finally going to deploy all of this into your B.E.S.T robot. And it's a great way to integrate simulation when you get to program your robots for the competition. And what are the benefits? If it's basically you can find things that are going wrong and you can fix it before you deploy it to your robot, which makes it low cost, low risk. It's easy to understand models and logic. I'm going to show you how you can see different blocks and create models. And instead of writing many lines of code by hand, Simulink will automatically generate code for you that behaves the same way as the model that you created in Simulink. So you can deploy it directly to your embedded processor. It's got extensive libraries for controls and robotics. I'm going to show you how you can access the library browser for Simulink. And you can share this with your colleagues, right? So in this case, you just have to share one model instead of sharing different files. So why Simulink? Like it says here, it's used widely in the industry. It saves you a lot of time, and Simulink makes the programming process easier. It just helps you with, you don't have to waste too much time in syntax and debugging. So again, when you open out this PDF, it's going to give you a bunch of information, and it's also going to give you a recap of what we're going to do with the session today. So make sure you look at that for sure. So again, we're in Unit 3, which is Intro to Simulink. And then you've got the PDF here, and you've got a bunch of exercises there. Okay, so that is Simulink. Just a quick intro to what it is. Let us now look at how we can open Simulink. So this is the Home tab, the main page of MATLAB. And over here on the tool strip, you will find that there is a button here that is called Simulink. So you can go ahead, click on that. And that opens up this window, which is called the Simulink Start page. And if you click on this, it helps you create a blank model. I'm going to close this. And another way that you can do it is under the Home tab. There is a new button. So if you go ahead, click on that drop down. We've used this last session because we created a new script, we created a new function, but if you go all the way down, you'll be also be able to create a Simulink model. So you'll see an option for that. Go ahead, click on that. And it opens up the same Simulink start page. So there are these two ways how you can get to Simulink, either from the button or you go to the new button and then you click on Simulink. So once you've got this Simulink start page, go ahead and open it out to create a new model. And this basically opens up the Simulink canvas for you. So this is how Simulink looks. You'll see that you've immediately, when you look at some of the tabs at the top, you'll see that you've got the simulation tab, the debug tab, the modeling tab. And once you've got your Simulink model or your canvas open, the next thing that you want to look at is how you can open the Simulink libraries, because the libraries are what you're going to use to create your models. So again, under the Simulation tab, you will find a button that's called Library Browser. So go ahead, click on that. And that's going to open up the library browser for you over here to your right. And if you click on this button with the white, blue, and red, it's going to launch as standalone, which I think is easier for me, and I personally like it. So you can feel free to do that if that's what you like. I find it easier to browse my Simulink libraries when it's launched as a standalone tab. So this is the library browser, and you can browse all the blocks that are available, and you can create models from here. So it's got options for like continuously used blocks, where you'll find blocks like the constant block, the gain block, and different kinds of blocks like the scope, the sum, switch, saturation. Some of these I will show you how we use today. But once you found the block that you want to use, the way that you move it or use it in Simulink is just clicking on it and dragging it into the canvas, and then you will see that you get your block on the canvas. And then there are a bunch of other libraries here. You will also find something called sinks, where you will find things like display, scope. You'll find sources, where you find like, that's basically your input. So you'll find things like constant, digital clock. If you go down, you'll find ramp. You'll find sine, you'll find step, and so on. And if you go all the way down, you will find that there is a robotics playground option. So if you click on that arrow, it's going to give you a drop-down menu. And over here, you'll be able to find more things like sensors, actuators, environments, and so on. So there's a bunch of libraries here. And what we're going to be using is the robotics playground one. But like I mentioned here, there's different kind of libraries that you can use with Simulink, right? So people use it for reinforcement learning, or they use it for digital signal processing, they use it for communications. So based on what you're trying to do and what your project is, there are different kinds of libraries that are available for you to pick blocks from. So we're going to stick to robotics, obviously, because we're talking about B.E.S.T robotics, but in general, it's used by engineers when they're trying to do any kind of project. There's an aerospace block set, there's an automated driving toolbox. So there's different kinds of toolboxes that are available, and you can pick blocks from there. So that's how you get some blocks, and you can find the blocks that you want from your library browser and then just drag it into your canvas. I'm going to go ahead and I'm going to close this out. And let's try to create a simple Simulink model. So one of the examples that we used last week was to create or to find the hypotenuse of a triangle. And we know that the formula or the equation for that is given a triangle with two sides, A and B. The hypotenuse C is equal to the square root of A square plus B square. So let's try to do that. So now we have a constant block here, and any block in Simulink in general, if you double click on the block, it's going to open out this window which gives you a description of what that block does. Right, so it says outputs the constant specified by the constant value parameter. And in general, if you're lost, you don't know what this block does, you just double click on it and you'll be able to find a description. And when you double click and when this window opens, you'll also find that you have areas where you can change some of the parameters. So if you want to change things about the block, again, double click on the block and change things in this window. And if you are not sure what this block does, there's always a button at the bottom, which is called help. So if you click on that, that's going to take you to the documentation, and it's going to give you an examples of how it's been used. It's going to tell you what the parameters are and how you should change them and so on. So always go ahead and click on that if you need help with any of these. Now that was the constant block. Let's go back to the library browser and let me try to look at math operations. Now, under math operations, we can try to find a block that says math function. I'm going to drag that into the canvas. So I've got my constant block, I've got my math function block, and again, any of these blocks, you can just hold on to the block and just drag it around the canvas. So since we're trying to do A squared plus B squared, we're trying to find the hypotenuse. Let's go ahead and you can rename these blocks. So the constant block, I'm just going to click on the block and I can rename it. So I'm going to change it to A. And I'm trying to get A squared. And to do that, again, I'm just going to double click on this. It's going to open out the block where it says mathematical functions. It gives me a description of what the block does. And I'm trying to find the square. So I'm going to choose the function square and I'm going to hit OK. And that just changed up for me to square. So now to find the hypotenuse, again, you need to do square root of A square plus B square. So we need another constant. And I don't have to go back to the library browser to get another constant. I can just right click and I can just drag it, and that just creates a copy for me. And you see that it's been named A1. I'm going to go ahead and I'm going to rename that to B. And similarly here, I just right click and I drag and it just creates another copy of that same block for me. And the way that you connect signals is from this arrow that's pointing out. I'm going to connect all the way here to my square block. So now I've managed to get A square plus B square. and I've got A squared and I've got B squared separately. And the next thing that I want to do is I want to be able to add it. And to be able to add it, I need a sum block. So if you know what blocks you need, you don't have to go to the library browser again. You can just click on the canvas and just hit sum, and you'll see that the sum block will come up. And once this block comes up, you can feel free to resize it if you want. Just hold on to the corners and drag it and double click on that block. And again, it says it's the sum block. It helps you add or subtract inputs. You can change the shape. I can change it from round to rectangular if that's what I want. I want to be able to add. So I'm going to have 2 plus signs and I'm going to say okay, and you will see that that automatically just changed up for me. So now I'm going to try to add A square and I'm going to try and add B square. And once you've done that, the next thing that I need to do is I need to use the square root. So I've got A square plus B square, and I need the square root of that to be able to get my output C. And for square root, again, I'm going to click on the canvas and I'm going to say square, and you'll see that square root comes up. And you can just click on the canvas and do this every single time that you know what block you want to use. And I'm going to make this connection. Now, once I'm done with that, I've done A square plus B square. I've added it with the sum block, and then I did the square root of that whole thing. And now I'll get my output or the length of my hypotenuse C. Now, to be able to see my output, I need to be able to use a display or something of that sort. So I'm going to go back to my library browser, launch it as standalone. And if you go to, like I mentioned, you have something called sources, which is where you put all your inputs, and you have something called sinks. So sinks is basically just some blocks where you can see your output, and you'll use some things like display and scope are, some of the very popularly used sinks. So I'm going to go ahead and I'm going to just drag the display block here. Now, if I knew that I wanted the display block, I can just click on the canvas and type display, and the same thing is going to pop up. And then anytime that you want to rename any block, click on it. The name is going to get highlighted, and then you'll be able to change it. So I'm going to go ahead and I'm going to change it to C. So now this is our model to be able to create the, to be able to find the hypotenuse of a triangle with sides A and B, and we're trying to find the hypotenuse C. So now for Simulink, under the simulation tab, again, you will find a green play button that's called run. Go ahead and click on that. And you will see that you will find the square root of you will be able to find the hypotenuse of the triangle. Now, I didn't change the input values or the constant values. So let's go ahead and do that and run it again to see what we get. So I'm going to double click on the constant block, and I'm going to change the value from 1. I'm going to go ahead and change it to 4. And you'll see that that pops up right there. And for B, I'm going to go ahead and I'm going to change it to 5. So let's say we have a triangle with sides 4 and 5. And if I hit run, I'm going to get my hypotenuse C to be 6.403. So that is how you create your Simulink model and you run your Simulink model. Okay, let's see if you've got any questions. I was unable to see how you got A and B. Okay, so it looks like you figured it out, but in general, if you want to change any of the blocks, just click on it and you should be able to click on the block, make sure it's highlighted, and then you should be able to change it to like B or F or whatever you want. Okay, I don't see any other questions. I'm gonna keep going. Now, this was a relatively simple model and we didn't have too many blocks. But when you are making your models for your robots, You will probably have larger Simulink models. You will have more blocks that you're going to be using. And so just to make it easier, you can use something that is called as a subsystem to help scale large Simulink models. And you can group certain blocks to make the models just easier to understand. And the way that you can do that is if you just select a bunch of blocks that you want to group together, you'll find that there are 3 dots that pop up, and that is the first option that you will see. It's going to be called Create Subsystem. So if you click on that, you will see that a subsystem has now been created. And of course, you can do the same thing with all of this, like you can resize it, move things around, and so on. So I'm going to just go back. Again, just select it all. 3 dots. First option is Create Subsystem. The other thing that you can do is you can just select all the blocks that you want to group, right-click, and you will find an option that says Create Subsystem from Selection. Click on that, and your subsystem gets created. Now, again, with your subsystem, the other thing that you can do is you can go ahead and you can rename it, just like how you can rename blocks in Simulink. Make sure it's highlighted, and you can go ahead and you can call it hypotenuse. So now that you've created your subsystem, you can double-click on your subsystem, and that basically opens up what is inside your subsystem. So you'll find all the blocks inside. You'll find your square blocks, your sum block, square root, and so on. And these are your input and your output ports. So you can go ahead and you can change these. So you can change the input. You know your input was A and B. So go ahead, change that. And your output, you can change it to C. So you can customize it based on your model. So you can rename your input and output ports. And once you're in your subsystem, now how do you get out of it, right? Like, so when if you want to go back, one of the options is to select this upward arrow that you see here. So if you click on that, it takes you back to your upper level of your model. And again, if you double click here, the other way that you can do that is here, you've got this title bar over here, and you're inside the subsystem hypotenuse. And if you want to go back to your main Simulink model, just click on the model name, and then it'll take you back to the top level. So that's how you can navigate your subsystems. There's a question on how do you change the minus sign to the plus sign. So I'm assuming that's in the sum block. So if you double click on the sum block, you go ahead and you can just change it over here, right? So you can go ahead and make it plus and minus if that's what you want. And then you can see that it just reflects over here. This is now plus and a minus. So that's how you navigate your subsystems. But like I said, it makes a lot of sense to have subsystems when you have very elaborate models, and subsystems can help just make it easier to understand and just make your models also look better. So now we used a bunch of blocks to create the logic for the hypotenuse. But the good thing with Simulink is that Simulink has a bunch of libraries that helps you simplify these models and speed up your programming. And that's the whole point of using Simulink, right? And so if you just click on the canvas, like when you're looking for certain blocks and you type out hypotenuse, you will find that there is already a block that is called hypotenuse. And this block basically does the same thing as all the logic that we just wrote out here and we just created. So there are already some pre-existing blocks, and there are a bunch of things in the libraries that you can use in your model. So you don't have to go and reinvent the wheel. Like, there are things that are already done for you, so you can just go ahead and use these blocks. So let's see how that works. So this is the hypotenuse block that Simulink has already got. So you can just, let's go ahead and let's just replace this one. Let's make the same connections. And I'm going to go ahead and I'm going to run this again, and you will see that you get the same result, right? So this block basically does the same thing as the logic that we just wrote out. So if you double click on that, it basically tells you that the block that it is, the description, and there are a bunch of functions. So one of the functions that we used was square, but there's already a hypotenuse over there. What is the square root block called? So you just click on the canvas and type out square root, and then it's going to come up for you. And most of these blocks you will just find in the library browser, right? So if you want to look at math operations, you'll be able to find a bunch of blocks like the add, divide, the absolute value, gains, math functions. Math function is what we use to find the square, so you can go ahead, drag that in. If you double click on that, it opens up this window. You can try to do exponential, you can do log, square, hypotenuse, reciprocal, and so on, magnitude raised to 2, and so on. So again, all the blocks that you have here, when you just click on Simulink, are a bunch of commonly used blocks. So based on what you're looking for, right? So if you're looking for a dashboard, if you're looking for math operations, matrix operations, sinks, sources, user-defined functions, it's just based on what you're looking for. And if you need more stuff, we're using the robotics playground. So go to the robotics playground, and there are a bunch of more blocks that are available right here. So I don't see any other questions. So I'm gonna go ahead. So again, this is under Unit 3. You've got the PDF. Under exercises, there are a bunch of models here where you've got your hypotenuse start. Get started here. If you get stuck, look at the solution. There's an example for how you can create the subsystem, and then there's also the simplified version. So basically everything that I just showed you is all available as Simulink models right here. So you can check them out. Let's go ahead and open out time-based sources. And when you look at time-based sources, so now we basically used a constant in our last example. We used the constant block. So let's type that out. We'll get the constant block. So we use this constant block, and the constant never changes with time. It always will output a signal of 1. And we're going to just look at this example to see these sources where that are changing with time, right? So the output signals will change with respect to time. Let's go ahead and do that. I'm going to go ahead and just quickly run this. Before that, let me show you how I got these blocks. So if you go to the library browser, And if you go to sources, under sources, you will be, so we're using the ramp, sine wave, and step, right? So under sources, you will be able to find that we've got the ramp block. So you can go ahead and use that. Then when you go down, you will find the sine wave and you'll find the step. So you can go ahead and drag that into the canvas whenever you want to use it. And if you go to sinks, you will be able to find the scope. We got display from here as well. Now we're going to just drag scope and use that. So let me go ahead and let me just run this. And once you run this, if you double click on scope, okay, so it has opened out, but it's opened out. Okay, I'm just going to have to resize my screen because it has opened up in a very weird way. Okay, I've managed to get it. Okay, give me a quick minute. I've got to resize it again. There we go. There we are. So, so when you hit the play button and then you double click on the scope and you open it out, this is what you're going to see. You're going to be able to see your ramp signal, you're going to be able to see your step signal, and you're going to be able to see your sine wave. And you will see that it goes from 0 to 10. And the reason that it goes from 0 to 10 is because we've got our stop time to be 10 right here. So if you go ahead and you change that to say 20, hit run, double click on the scope, you will see that it moves now from 0 all the way to 20. And if you go to the View tab in Scope and you go to Layout, if you want to view each of these signals separately, you can just do that. I'm going to select these 3 boxes. And when I do that, you'll be able to, it'll split all your signals for you and you'll be able to see them all in a separate graph. So I've got my ramp, my sine, and my step. So again, it's under the View tab. You go to Layout and you can choose how you want to view your signals. And this is just important because you're likely, when you're programming your robots, you probably want to take time into account, and simulations just perform calculations over a period of time. And so this is just helpful for you to see and know. Okay. I'm going to go ahead, close this. I don't see any questions in the chat, so I'm going to move. Okay, awesome. Doesn't look like any of you have questions, but that basically brings us to the end of Unit 3, which was Intro to Simulink. So we learned how to open out Simulink, how to browse the Simulink libraries, how to connect Simulink blocks, run the models, create subsystems, and so on. Another important thing that I just wanted to show you is when you open out that PDF and you go all the way down, there is a video that is available at the end of it. It's a quick video. It takes about 10 minutes, but it's a good introduction to what Simulink is and how you can get started. So I would recommend that all of you check that out. And I think it'll be quite useful for you. So let's go ahead and go to Unit 4. So now we're going to go to Unit 4, which is Robot Controls. Go ahead, double click on that. And again, you've got a PDF already. And if you go to exercises, you will be able to find a bunch of Simulink models. And I'm not sure if any of you realize, but your Simulink models all have a .slx extension. The MATLAB scripts that we used last week had a .m extension. So if you see a .slx extension, that's how you know it's a Simulink model. So let's go ahead and open out one of these models. So let's do the move forward _ start. And all of you should also start with the start model. And if you get stuck, look at the solution models, because you always have the solutions that are available to you. So go ahead and open out the move forward. So once you do that, this is what you're going to see. You will see that you've already, your Simulink canvas already has a bunch of blocks that have been pre-populated for you. Now, where do you find these blocks? Again, if you go to the library browser, launch a standalone, and if you go all the way down to Robotics Playground, if you go to environments, you will be able to see the obstacle environment here, and that's exactly what we used here. And then if you go to basic sensors and actuators, you'll be able to find the robot motor. That's what I've dragged in here. And then we have some constant blocks. So if you go to the utilities and hardware, you'll be able to find the constant block. So all of this comes from the Robotics Playground library, from the library browser. And that's how we got all of these blocks. Now, once you've done this, again, if you, like in any block in Simulink, if you double click on that block, it's going to open this out for you. It's going to tell you what that block does. There's a bunch of options here where you can change some settings, like you've got your obstacle settings here. There are some arena settings. There's robot settings, and so on. And when you go to the left and right motor, if you double click on that, it's going to tell you about the motor. And an important piece of information that it gives you is that the input is a number in the range of -127 to 127. So it's basically telling you what is the range of that motor for it to be able to function well. And so it's between -127 and +127. So sometimes if you don't know what values you need to be giving to your motors, just double click on it and it's most likely going to give you that information. So now once you've done that, let's go ahead and just make a connection from our constant blocks to our motors. And our constant blocks, again, let's double click on it and let's go ahead and change its value. Let's give it a value of 100. And the reason that I'm giving it a value of 100 is because it's the motor only functions in the range of -127 to +127. So any value between that should work. So again, let's go ahead, change this to 100 and hit OK. And then under my simulation tab, again, I have a green run button. So I'm going to go ahead and click on that. And you will see that my robot is moving forward. So it's going to move forward and it's hit the obstacle. And also the simulation keeps running until its time is 10 seconds. And the reason for that is because my stop time here is 10. So you can feel free to go ahead and you can change that. If I change it to 5 and I hit run, you'll see that the robot moves forward. And then it'll stop at time 5. So you can see that here in the corner here, when time is equal to 5, it'll just stop. So it doesn't hit the obstacle. So you can change the stop time of your simulations based on whatever you want. And there are a bunch of options here where you can play this simulation again. You've got an option to step back, step forward, and rewind to the beginning. So once you've had your simulation, once you've run your simulation, if you want to play it again, you can just do it here in your Mechanics Explorer, and you don't have to keep running it from Simulink. Does anyone have any questions with regard to this? Okay, I don't see any questions. I'm going to move ahead. Let's go ahead and close this. And I'm going to open out another model. But before we do that, let's just go back to our presentation real quick. And let's look at tank control. So when you guys are programming your BEST robots, you will always have a joystick that you will probably use for your BEST robot, and you're going to want to program these joysticks to control the motors. So we'll use some input controls in Simulink. So one of the configurations that you will probably use is the tank configuration, where you're driving the left and right wheels of a robot through separate controls, right? So you'll probably use two different joysticks. You will probably use motor one, you'll use joystick 1 for motor 1, and you'll probably use joystick 2 for motor 2, and so on. So tank control is where you're driving the left and right wheels through separate joysticks. Let's go back right here, and let's open out the tank control _ start model. So when you open out this model, again, you will find things have already been pre-populated for you. You've got your obstacle environment, you've got left and right motors, and here you've got something that's called as a knob. So if you click on the canvas and you type out knob, you'll be able to find this knob block that we've used here. And so basically what we're trying to do here is we're going to use these knobs to control our left and our right motor. And the way that you do that is the first thing that you've got to do is you've got to connect your knob to the constant block here. And to do that, double click on the knob. It's going to open out this window. And then you want to connect this knob to the left constant. So let's go ahead, click on that, and you'll see that this pops up over here. Click on this circle and connect it. And once you do that, hit OK. And now you will see that when you click on the knob, you'll see that your left constant, your left speed constant has been connected to it. And you don't see that here, right? When you click on this knob, you see that the right speed constant does not get highlighted, which means that it's not connected. But this does automatically get connected once you do those steps. So let's go ahead and do that for the right side as well. So double click on the knob. Once you've done that, you want to be able to connect this knob to the right speed constant. So click on the right speed constant. Click that, then this is going to pop up here. Click on connect and hit OK. And now you can see that this knob has been connected to this constant. So now once we've made the connections, the next thing that we've got to do is let's just double click on each of these knobs, and you will see that there's a section here that's called minimum and maximum. So let's go ahead and put that in. We know that our motors can take a minimum value of -127 and a maximum value of 127. So go ahead and put that on, and you will see that immediately your knob changes from -127 to +127. And again, when I double click on this one, I'm going to go ahead and change the minimum value to -127 and +127. And this one just got updated as well. Now, once I've done that, the next thing that we're going to do is I'm going to change the stop time from 10 seconds. I'm just going to change it to INF, which basically means infinite. And it just basically means that my simulation is going to keep running until I ask it to stop. So once I've done that, I'm going to go ahead and I'm going to hit the green button. My robot is moving. I'm going to just quickly stop it for a second. I'm going to try to resize this just so that you can see it side by side. And let me try to resize this as well. This just makes it a little easier for you to see when we're trying to move this. I'm going to go ahead and run this again. And when I hit run, I can move these knobs and you will see that my robot is going to move. And if I try to bring it there, my robot is going to try to move backwards because it's in the negative direction. And if I wanted to move forward, I try to give it a similar value in the positive direction and it'll move forward. So basically you can move your knobs around and you can control your robot. See that it's moving backward now. I can try to move it. And then maybe try to move it backward again. So basically you can, this is like one way for you to be controlling your robot in tank configuration. And this simulation is going to keep running until you stop because I've set the stop time to infinite, INF. So I'm going to go ahead and I'm going to stop this. And once I stop this, my simulation ends. So this is basically how you can control your robot and you can drive the left and the right wheels through separate joysticks or through separate controls. And this was tank configuration. Does anyone have any questions? Okay, if you have no questions, you're having trouble connecting with the knobs. So once you've got your knob, click on your, okay, let me just get a new knob. I think that would be easier. This is a knob. I'm going to get a constant block as well. So this is my knob and this is my constant block. And now it's not connected because you can see that it's grayed out a bit. So if I click on my knob and open this out, it's going to open out this dialog, this window for me. And you're not going to see anything over here, right? In the connect section, you don't see anything. So I'm going to click on this constant block because I want to connect it to this constant block. And when I click on that, you will see that this connect section automatically gets pre-populated with this constant. So then I just have to make sure that I click on this connect circle and I have like a black dot in the middle. And once I do that, and I can go ahead and I can also change my maximum and minimum values. And then if I hit OK, you will see that your knob is not grayed out anymore. And when you click on the knob, your constant also gets highlighted because it's connected to this constant. I hope that helps. Okay, so if yours didn't run right, did it not run at all, or did it not run right because of the knob values? So that's one thing to check, right? So if you wanted to turn or move in a direction, you're going to have one knob pointing in the negative and the other pointing in the positive direction. And if you wanted to move forward your robot, then both your knobs need to have a positive direction, and backward, they both have to be in the negative side. You connected the knobs right now, but no viewing window opened and the knobs were unresponsive. Okay, so the first thing that I would do is I'd first check if my knobs are connected. So click on your knob and make sure that it is highlighting the constant. If that is happening, you know that your knob is connected. Feel free to run it again to see if your Mechanics Explorer pops up. If it doesn't pop up, you're probably running into the same issue that I ran into. So just close it down and try to open it out again, and then your window should open. And sometimes maybe you already had it open, so just check your tabs. Click on the MATLAB icon at the bottom and check if your Mechanics Explorer has been open already. Okay, so the next thing that we're going to look at is after tank configuration is obviously arcade configuration. Now going to arcade configuration. This is the other configuration where you're controlling your robot, means you control the forward, and the backward with one joystick and the right and left with another joystick. And you can also do both directions of one joystick can also be used. So this is just a different configuration. If you're not using tank, you can, and if you're using arcade, this is the arcade configuration. So let's go ahead and open out arcade control underscore solution. I'm going to open out the solution script just for the sake of time. So let's go ahead and double click on that. And while that's opening out, let's just go here. And this is the PDF from these lessons, so make sure you check them out. Gonna just try to open that out. So there's also a possibility that sometimes your models are taking a lot longer to open because you've also got WebEx open. So this is the arcade control solution. Now, again, we've got knobs. The knobs have already been connected to the control, to the constant blocks. And I've implemented some logic here. Now, if you go back to this PDF and you go all the way down, after tank configuration, you'll find arcade configuration, and then you'll be able to see the logic that has been applied here for the arcade configuration. So that's exactly what you see in your model. So let me just open that out and let me show it to you. So this here is basically the logic for the arcade configuration. We've got our motors. We've got our knobs that's connected to our constant blocks. And here I've used a sum block, and I've had my sign to be two positive signs, plus and plus. And here I've got my same block, sum block, but I have my sign plus and minus. And I've basically made these connections. And here I have something that's called as a saturation block. So if you click on your canvas and hit saturation, your saturation block should come up. And I've made these connections. So again, if you read that PDF, you'll be able to see the logic that we've applied for arcade control. But let me just quickly show you what the saturation block does. Now, this is a new block. We've not used this before. And the reason that we have this block is because we're using these sum blocks. So these knobs are connected to these constants. And when we give a value to these constants, now let's say that we're running both these knobs at positive 127 and positive 127. So when you look at this block, it says it's both addition. So if you're giving 127 and 127 from both these blocks, it's going to be around 254, right? But we know that our motor can only take a value of negative 127 to positive 127. So that's going to be, the value is going to be very high for our motor to take, and that's why we use a saturation block. So basically the saturation block just clips the ends of the signal. So if you double click on the saturation block, it says it basically limits input signal to the upper and lower saturation values. And I've set my upper limit to be positive 127 and my lower limit to be negative 127. So it's basically just something that's trying to protect your motors and clips the signals at the end. And let's go ahead and let's run this. So I can go ahead, and this is forward and reverse. So this is going to make the robot move forward. This is going to, if I move it to the back, it's going to make my robot move reverse or forward again. And this one, this knob at the bottom is going to make it move left, or it's going to make it move right. If I wanted to move reverse, I just move the first knob in the negative direction, backward, and then forward, move to the positive direction. So basically this first knob is used to make the robot move forward and backward, forward or reverse, and left and right is the second knob. Now, another thing that you can do is when your simulation is running, you can go ahead and you can just click on these signals and you'll be able to see the value that is coming from these signals, right? So you can basically see what the value is from your knob that you're applying to this constant, and then there's a value from here as well. So you can see the output of the constant blocks pop up here. And if I move it forward, and you will see that these values change when you change your knob. So this is a good debugging feature which helps you figure out if your values are wrong, where if the robot is acting weird, you can check what values are going in or coming out of this block. So when make sure your simulation is running, and when it is running, you have to just click on the signal so you can find out the values at different places. So here you've got a value of 62.2, and here you've got 37, and out of the sum block, you get 99. So this is a good debugging feature as well. So I'm going to go ahead and I'm going to stop the simulation because my stop time is set to infinite. Does anyone have any questions regarding this? So again, when you go back to your lesson, you'll find that you've got a bunch of models here. We looked at the move forward model. We've looked at tank control, and we've got arcade control. Again, there's a start script and there is a solution model. So get started with the start_start model, fill it out, and if you get stuck, look at the solution. And the PDF is super helpful to help you understand what's going on as well. So basically in this unit, we just learned how to interact with robots using dashboard controls. So you used a knob to control your robot, the left and the right motor, and you learn how to program in tank and arcade driving controls for gamepads. This is pretty useful. You're likely going to use this when you're programming your B.E.S.T robots. Feel free to let us know if you have any questions. And if you don't have any questions right now, that's okay. We're going to send you the recording, but through the week, if you have any questions, you can always send us an email. We're happy to help you. Okay, I don't see any questions in the chat right now, so I'm going to go ahead and keep moving forward. Let's look at Unit 5, which is using a distance sensor. And here again, you've got a PDF, and there are some exercises. So I'm going to go ahead and open out the avoid wall _start Simulink model. And this is what you're going to see. So all of these blocks that you see here are pretty familiar to you. So you've seen the obstacle environment, the left and right motors, the constant blocks. This is a subsystem, which is the arcade blocks that we used in the previous unit. It's just been made into a subsystem, so it just makes it easier. And a block that you haven't seen before is the distance sensor block that we've got here, and we've got a display here. Now, how do you get this distance sensor block? You can click on the canvas, type distance, and you will see that the distance sensor block comes up, and you can click on that. So that's how you get this block, or you can also go to the library browser, go to sensors and actuators under the robotics playground, and you'll find the distance sensor, and you can just drag that into your canvas as well. So that's how you get all of these blocks. And what is the distance sensor? It's basically an ultrasonic sensor that is commonly used in robotics, and it gives you information regarding the proximity of an object. So let me go ahead and let me run this. So my simulation is running. You can see that the display here, you can see that the value keeps changing. Right, it's based on where your robot is. Let me go ahead and let me run that again, so you can see it better. You can see that in this display block, you can see that the value keeps changing. It's basically sensing this blue wall and the distance to the blue wall. I'm going to go ahead and I'm going to stop it because it's going to crash into that, and our stop time has been 20. But basically, you use the distance sensor to sense any obstacle that's in your environment. And if you just actually, I'm just going to pause this real quick. If you zoom into your robot, you'll be able to see your distance sensor right here at in the front. Okay, awesome. So now that we've got that, now when you look at this model, we're basically telling the robot, we're only getting the robot to move forward. So we're giving it the forward joystick, we're giving it a value of 50. And for left and right, we don't want it to turn, so we're just giving it a value of 0. But as you saw, when the robot keeps moving forward, it's going to hit the blue wall in the front. And so to prevent that, we're just going to write out some logic. And to do that, we're going to use something that's called as a switch block. A switch block is like it's like an if-else statement. It's similar to that. And basically, you use a switch block when you have a decision to make. Or when you've got one decision to make and a simple decision, you can use a switch block. And to do that, we're going to so basically we just want to modify this model to prevent the robot from crashing into the wall. And to do that, let's click on the canvas and type switch. So we're going to get the switch block. Once we've got the switch block, just double click on the switch block. And again, it opens out this window where it's going to give you a description of what it does. And you can set a threshold in the switch block, right? So I'm going to go ahead and I'm going to set the threshold over here to be 1. And the reason that I set it to 1 is basically because I want the robot to stop when it's 1 meter away from the wall. And then the criteria for passing first input has already been put in there, but there is a drop down. You can choose whatever you want based on what you're trying to do. But I basically put a threshold of 1 because I wanted to stop 1 meter before the wall. So I'm going to hit OK. And that's my switch block. So I'm going to go ahead and just delete some of these blocks. I'm going to make some changes. So the input to our switch block is first going to be from our distance sensor. And I'm going to copy out some of these blocks. And I'm going to add it here. Okay, so basically all that I've done here is we're trying to make the robot not crash into the wall. So I've used a switch block where I've given it a threshold of 1 meter, which basically means that the robot needs to stop when it's 1 meter away from the wall. And the input to this switch block is coming from the distance sensor. So the distance sensor, based on the value of the distance sensor, it's going to decide what it's going to have to do. And I've given it a value of 50. So basically, the robot is going to continue to move forward with a speed of 50 until it reaches the 1 meter mark. And after it reaches the 1 meter mark, I want the robot to stop. And so I've given it a value of 0. So once I've done this, I'm going to go ahead and I am going to hit run. And when I hit run, you see that the robot just stops and it doesn't, and it doesn't collide with the wall. But when you look at the simulation, you can see that the simulation is still running, and it's going to keep running until time is equal to 20 because that's what my stop time is. So I'm going to play this again, and you can see that the robot stops even though the simulation is still running. So the robot is stopping right now. It's stopped, but you can see that the simulation is still running and the time still keeps increasing. So that basically meant that the switch block helped, and the switch logic that we applied did help stop the robot from crashing into the wall. So switch blocks are pretty nice to use when you have a simple decision to make. If you've got to decide something, when you have one decision to make, you can use a switch block. But if you have more than one condition, then you're going to have to use something like a MATLAB function or a state flow chart, which are things that we will cover in the next session. But switch blocks are relatively simple and easy to use for simple tasks. Does anyone have any questions related to this? Okay, I don't see any questions. I'm gonna go ahead. And the next thing that I'm going to do is I'm going to open out the track wall underscore solution model. I'm going to open out the solution just for the sake of time. But again, here, what we're trying to do is we're basically trying to track the wall. So we're making the robot not just move forward, we also want it to move left or right, and we want it to go around. So here again, all of these blocks are pretty similar, but in this case, we're going to be using two switch blocks. And so the first part is what we did previously in the last exercise. So we use a switch block, we're making it move with a speed of 100. The threshold has been set to 1, which basically means that when the robot is 1 meter away from an obstacle, it has to continue to move forward, and when it hits the 1 meter mark to the obstacle, it doesn't move forward anymore, it just stops. But in this case, we're also wanting to make the robot move left or right. So we're using another switch block, and we have a threshold of 1 meter here as well. So basically the robot will not move until the distance until it is 1 meter away from an obstacle. When it's less than a meter away from an obstacle, the robot will turn left or right. And the direction, whether it moves left or right, is based on the value that you give it. So if I give it a positive 100, it's going to move in one direction. If I give it a negative 100, it will move in the other direction. And what I've got here is these colored boxes that you see here are from here. You can just drag it from this tool strip over here, and it doesn't really do much. It's just nice to be able to put your blocks together as groups, and it's just for visual purposes. So this just makes it easier to understand that these blocks are for making the robot move forward, and these blocks are for the robot to move left or right. So how do you make the middle block and that switch block fed into? So you can just make a connection like this. Go from that arrow from the middle port, click on it and drag to wherever you want to connect it to, in this case to the distance sensor. So once you've done that, go ahead and let's run this. And you can see that the robot is moving forward, and then it turns in this case. So this prevents the robot from crashing into the wall, and this distance sensor is basically trying to sense what is in front of it. So at any time, if there's any obstacle in front of the distance sensor, you will see that it will move. And this is going to keep happening. So I'm going to go ahead and I'm going to stop the simulation right here because my stop time has been set to infinite. But you can go ahead and you can play around with this. So if you want to like change the threshold, if I change it to 1.5, and let me change this to 1.5 as well. And if I hit run, you'll see that the robot is now mostly moving within the middle of this environment. And the reason for that is because I've set the threshold values to be higher. I've set it to 1.5 as opposed to 1 meter. So it's basically going to be tracking the walls and just moving in the middle portion of it. So you can go ahead and you can change that values to whatever you want it to change it to. So this is how you get the robot to basically track the wall. You used 2 switch blocks, one to make the robot move forward, and this is one to make the robot move left or right. And if you want the robot to turn left as opposed to right, just go ahead and change this from 100 to a -100. Does anyone have any questions? Feel free to put your questions in the chat. But just a quick reminder that we're going to be sending you a recording and resources today. If you, we're going to be sending it, the recording from today, we're going to be sending it to you tomorrow. If you have any questions, feel free to reach out to us at roboticsarena@mathworks.com, and we'll help you if you're stuck with your models and so on. So make sure you follow lesson plans for Unit 3, 4, and 5. That's what we covered today under the Robotics Playground. And we have a quick assignment for you for next week. We just saw how you can track the wall using the distance sensor. So for the assignment, we want you to track the wall and reverse the direction after some time has passed. So basically after about 20 seconds, reverse the direction and track the wall in the opposite direction. And we've given you a quick hint here which says use the digital clock block. So if I go back to Simulink, if I go to my library browser, it's probably open. I go to Simulink, and if I go to sources, I should be able to find my digital clock block. So you can use this for your assignment. So basically all that you have to do is get the robot to track the wall and then reverse its direction after 20 seconds. Good evening, everyone, and welcome to the 2024 Best Robotics Simulink Summer Workshop online series. Today is session 3. Thank you for joining us this evening. Some housekeeping. Please make sure that your mic is muted as we're recording this webinar, and we're going to be sending you this recording tomorrow. And if you've got any questions, as always, please feel free to put it in the chat and we'll address them throughout the webinar. So this is session 3, like I mentioned. So we've had 2 sessions before. If you haven't attended them, please make sure you reach out to us so we can send you the recordings to those sessions. Each session does build off of the previous session. So we're at session 3 today, and we've got our final session next week. So that's Thursday at 7 p.m. Central Time. So let's get started with today. So in our agenda for today, we're going to be going through the review of assignment 2, and then we're going to be looking at some MATLAB functions. In the first class, we did introduction to MATLAB. Second class, we did introduction to Simulink. Today, we're going to look at an introduction to state flow. And then finally, we're going to wrap it up with a maze solving robot. So first, just go over the assignment that we had from last week. So for the assignment, we basically asked you to program your robot to track the wall using the distance sensor, something that we did last week in our session. But for the assignment, you were asked to reverse the direction after some time had passed, for instance, about 20 seconds. And the hint was to use the digital clock block. So let's go ahead. This is my solution from that assignment. Now, all of these blocks should look fairly familiar from our last session. We've got our obstacle environment, our motors, our arcade module. We've got our distance sensor. We learned about switch blocks last week. And again, all of these are switch blocks. These are all constant blocks. And the only additional block that we had here was a digital clock block, where you can find that from the library browser. And just pop it out if you'd like. And if you go to sources, you should be able to find the block. So it's right here. It's digital clock block. And you can feel free to just drag it into the canvas once you find it. So once you've got all of that, what we've basically done here in terms of logic is we've basically said that this switch block has basically got a threshold of 1, so that's 1 meter. So when the input is from the distance sensor, we've basically telling the robot that when the distance to the wall is greater than 1 meter, continue to move forward. And when the distance is less than a meter, turn right if the wall is too close. And we've added an additional switch block here because we want to reverse the direction. And in this switch block, the threshold is going to be 20. And the reason for it to be 20 is because I want to reverse the direction after 20 seconds. And the input to this switch block is going to be my digital clock input. And I've also have a one of the constant blocks has a value of a negative 100, and that is to get the robot to basically reverse its direction. So this was the solution to last week's assignment. I'm going to go ahead and hit the run button, the green button at the top. And that should open out your Mechanics Explorer. And now you'll see that your robot is trying to track the walls. And it's going to keep turning right when the distance to one of the walls are less than 1 meter. And you now see at the 20-second mark that the robot begins to turn and reverse its direction, and it continues to track the wall. And remember that the distance sensor is in the middle of the robot, so it's always sensing the obstacle from this position. So I'm going to go ahead and I'm going to stop this because it's going to keep running until we stop it, because we set the stop time to be infinite. But this was the solution to the assignment. Does anyone have any questions? Feel free to put in the chat. So I see that if you're getting some errors when you're trying to run the model, it's mostly because you don't have the necessary support packages or toolboxes installed. Feel free to shoot us an email at roboticsarena@mathworks.com. I'm going to share that email at the end of this session as well. Send it to us, and we will send you a list of products that you should install. Okay, I don't see any other questions. And like I've mentioned before, in any Simulink block, if you don't know what it does, feel free to open it out. If I double click on the digital clock block, this is what's going to pop up. It says it outputs the current simulation time at the specified rate. The parameters, the sample time, I'm going to leave it at 1 second. Sample time is basically how often you are sampling or reading information from that block. So in this case, we're reading information from this block every second. Okay, so I see a question on where can I find the exercise files. So once you've got your MATLAB, under your Home tab, make sure you go to Add-ons, click on Get Add-ons. Just give it a quick minute to load. And then in your search for add-ons, just type out Robotics Arena, Robotics Playground, I mean. And you will find the Robotics Playground. So click on that. And if you have installed it, you will see that there's a green tag here that says installed. If not, you should find a button here that will say installed. So go ahead and install that. That would be step 1. And once you've got it installed, go to the apps tab here. And under your apps tab, in your drop down, under my apps, you should be able to find your Robotics Playground app. I believe I already have it open. So when you click on that app, it's going to open this out. And when you click on lessons, it's going to open out these lessons for you. That's where you're going to find the exercises and the lessons. So you'll find all of these units. And when you click on each of these units, you will be able to find the PDF and then the exercises. Awesome. I don't see any other questions, so let's continue. So what we're now going to do is we're going to be looking at using MATLAB functions, which is Unit 6. See it right here. So I'm going to go ahead and open that out. Again, like I've mentioned before, you've got a PDF with all information about that unit and exercise information. So make sure you review that after these sessions. And then you also have exercises and Under exercises, let's go ahead and open out the start script. And once you've done that, this is what you will see. Awesome. So what we're now going to look at is we're going to be looking at MATLAB functions, and we're going to create a MATLAB function, and we're going to create it using MATLAB code. So all this while, we've been using Simulink blocks to get our robot to do certain things like track the walls or move forward, turn around, and so on. But what if I want to write code instead of connecting blocks? So the MATLAB function block then allows for a MATLAB function to be connected to other Simulink blocks. So that's exactly what you see here. Most of these blocks are pretty familiar. You've seen the obstacle environment. This is the distance sensor. This is the left and right motor. And this is the MATLAB function block. Again, when you click on the three dots, when you highlight this block, you will see that there's an option to show the block name. So it'll show you that it's MATLAB function. And you can feel free to go ahead and rename that. You can call it whatever you want to. Let's just call it a function maybe. But you can call it whatever you're getting the robot to do. So you can rename that block. And if you want to find the block, you can just click on the canvas, type out MATLAB, and you will see that MATLAB function is one of the first items that pop up. And as usual, like you can do with any other block, you can resize it and all of that stuff. So now once you've got your MATLAB function block, the next thing that you obviously want to do with a function block is to be able to write code in it. And like you edit anything in Simulink, the way that you can edit this MATLAB function block is by double-clicking on the block. And once you double-click on the block, what the MATLAB function block does is that it opens out the MATLAB editor. And over here, you can go ahead and you can edit the function name, the inputs, and the outputs to match your Simulink block. So what we're going to try to do is we're going to do whatever we did in the last few exercises, which is basically track that same wall, but we're just going to be doing it with a MATLAB function. So let's go ahead and edit some of that. So first, I'm going to call the function, I'm going to call it track wall. So let's go ahead and do that. So I've done that. Once I change the function name, the next thing that I'm going to do is I'm going to change the input. I know my input is going to be coming from my distance sensor. So I'm going to type out distance. And I know that my output is going to be two outputs, right? It's going to be the left motor and the right motor. And whenever you have two outputs, you have to put it in square brackets. So I'm going to go ahead and do that. And then I'm going to start typing out left motor and right motor. So once I've done that, the next thing that I'm going to do is I am going to go ahead and write out the logic to the task here is to track the walls using a MATLAB function instead of using a switch block like we used in the last exercise. So once we've changed the function name, we've added the inputs, we've added the outputs. The next thing that we can do is we can implement the logic. And to implement the logic, I'm just going to use a basic if-else statement. So let's go ahead and do that. So I'm going to say if distance is greater than 1 meter, say left motor. I'm just going to write out the skeleton first, and then we will change it to actually write out the logic. Okay, great. So I just wrote out the skeleton of the if-else statement, and now let's go ahead and fill out what we should. So now to be able to track the wall, we know that we want the robot to continue to move forward if the distance is greater than 1 meter. So now if the distance is greater than 1 meter, we want the robot to continue to move forward. So let's go ahead and say then the left motor and the right motor will move with a speed of 100. It'll continue to move forward if the distance is greater than 1 meter to the wall. Else, if the distance is less than 1 meter, then we want the robot to turn. So let's go ahead and do that. I'm going to make it 50, and I'm going to make it the right motor. I'm going to give it a value of negative 50 so that it turns. And then I'm going to end the if-else block. So this was the logic that we implemented to be able to just track the walls. And again, to be able to navigate out of your function block into your main Simulink block, you can either use this upward arrow, or you can go ahead and just use this tool strip over here. So if I just use the tool strip, it's going to take me back to this part. And again, if I go back here, and if I try to go use this up arrow which says up to parent, it's going to bring me back to this model as well. So I'm just going to resize it. And once I resize it, you will see that your function has been renamed to track wall. You've got your input, which is the distance, and you've got left and right motor as your output. So everything that you did inside your function block editor is basically shown right here. Let's go ahead and make these connections now. And once you've done this, go ahead and hit run, and let's see if that works. So our simulation is running and our robot has been tracking the walls. And this is going to keep happening. So I'm going to go ahead and I'm going to stop this, but basically your robot is going to keep tracking the wall until you get the simulation to stop. So I'm going to stop the simulation. And I'm going to close the Mechanics Explorer because our stop time has been set to infinite. And basically, you just saw here that there are different ways to be able to do the same thing in MATLAB, right? So last week, we used the arcade module. We used knobs to be able to make the robot move around. Then we also used the arcade module, and we used the switch block like we did last week and in our assignment to get the robot to navigate around this environment. And right now we just used a function block. So these are all the same things, but you have different ways to do it based on however you think is best for your project. If some of you prefer to write code, make sure you use the MATLAB function block, and you can do the same thing as using Simulink blocks. So again, just to remind you, once you get the function block, click on your canvas, type out MATLAB, and MATLAB function should pop up. Click on that. And once you've got your function block, you can rename it. You can also double click on it, and that's how you edit and write out your code. And here we basically got the robot to turn right because we gave it a value of -50 at the right motor. If you want the robot to move left, just switch out the signs here. So you can just make the left motor -50 and the right motor +50. And again, if you want it to go faster or slower, you can feel free to change out these values, right? If you want the robot to move a little slower when it's moving forward, go ahead and change it from 100 to a 70 or a 75 or even a 50. But remember that when you click on your left or right motor, when you double click, the description does tell you that the input to these motors have to be in the range of -127 to +127. So those are the values that you can give your robot for it to be able to function. But that really brings us to the end of this unit, which was MATLAB functions. Just wanted to show you how you can use a MATLAB function block to be able to actually write code if that's what you would like to do. Does anyone have any questions regarding this? Okay, I don't see any questions, so let's go ahead and move on to the next unit. If anything comes up, feel free to put it in the chat. So the next thing that we're going to be looking at is we're going to be looking at Unit 7, which is Intro to State Flow. So go ahead and open that out. And there is a PDF associated with that unit as well. So you can feel free to open that out. So when you open out that PDF, you will see that this is what you're going to see. And basically, it tells you what state flow is. And there is a video here, which is very, very helpful for you to understand, some basics of state flow. So please make sure that you do open this PDF out and you actually watch this video. It's relatively quick. It should take you about 10 minutes, but it'll give you a good overview of state flow. And state flow in general is an environment for modeling and simulating logic based on state machines. It's basically a tool. It's like what you see here. It's a tool where you can draw diagrams and you can program the behavior of a robot using arrows and different states. So basically, state flow allows you to do these things graphically, and state flow works within Simulink. So please make sure that you check that video out, open out the PDF and look at it. It is definitely worth it for you to be able to understand just some basics of state flow and how it works. So let's go ahead and open out one of the exercises. I'm going to open out the track wall underscore SF underscore start. So now this is the model. And the objective from this model again is the same as what we've been doing. It's to basically just track the walls of the environment. So we did it last time using switch blocks. We just did it using a MATLAB function, and now we're going to do it using a state flow chart. So again, all of these blocks are from last session, the obstacle environment, left and right motor, and this is the distance sensor. And here, the other thing that we've got here that is new to you is a state flow chart. So the way that you can find it is you can just go to the library browser, click on it, pop it out if you'd like, and go all the way down, and you should be able to find state flow. And when you click on state flow, you'll be able to find the chart option. So you can feel free to drag that into the canvas. The other thing that you can do is you can just click on your canvas, type out chart, and you will find state flow chart, and you can get that into your canvas as well. So I'm going to go ahead and I'm going to delete these two. And the next thing that we're going to do is let's go ahead and double click on your state flow chart. What that does is that it opens out the state flow canvas for you. And let's go ahead and get started with implementing our logic. So here, like I showed you in that quick snippet, in the PDF, you've got a bunch of states and you use arrows, and that's how you write. It's like a flow chart. It's a graphical way of writing out your program. So the first thing that we're going to do in our state flow chart or in our canvas is we're going to drag some states from the toolbar. So what you see here on your screen on the left is basically your state flow toolbar. And you will find that there is a option here called state. So you can click on that and you can drag a state into the canvas. And similarly, if you want more states, you can just keep dragging more states into the canvas, or you can just right-click, drag, you can just right-click, drag, and hold to be able to create more states. So you will notice here that when you drag a state into the canvas, only the first state will have this arrow. It's called the default transition. We'll get into it a little bit more a little later, but this basically indicates that this is the starting state or this is the first state, right? So if I just delete all this again and drag, and there's nothing on my canvas right now, and if I just go ahead and I drag a state in, you will see that the first state has basically got the default transition, right? So our first state, so here in this model, all we're trying to do is track the walls. And as usual, that what we have to do for that is to basically move, the robot has to move forward and the robot has to probably turn right? That's the way that it's going to be able to track the walls. So the first state that we need is, we're going to say, let's call it move forward. I'm going to call that move forward. That's my first state. And then the second thing that the robot has to do is to move right. So I'm going to drag another state in. And when I drag my second state in, you can see that it doesn't have the default transition. And I'm going to name this state turn right. And now once I've got my two states, I know the robot has to move forward and then it's going to have to turn right. These are the things that the robot is going to have to do in this model. So I'm going to go ahead and I'm going to add code. So each state basically represents a block of code that will execute when this state is active. So I'm going to add the code and I'm going to set the motor speeds within each of these states. So let's go ahead and do that. So I'm going to say left motor is equal to 100 and right motor is equal to 100. And this is basically, again, to get the robot to move forward. It's going to move forward with a speed of 100 and 100. So left and right motor will move forward with a speed of 100. Now to turn right, I'm going to say left motor. I'm going to give it a value of 50. I just want the robot to turn a little slower when it's turning. So I give it a value of 50. You can feel free to give it a value of 100 if you want to, or any other value within the range. And I'm going to say right motor. I'm going to give it a value of negative 50 because again, I want it to turn right. So I've got my two states and I've basically added my code that will get executed when each of these states are active. Now, the next thing that I'm going to have to add is going to be transitions. And transitions are basically lines that connect the different states. So basically, when you look at these states right now, there is no way of going from from move forward to turn right. And so we're going to have to add transitions between these states. And the first thing that you need to know is that when we added this, there was already this transition that was added. And this is called the default transition. And all this basically means is that when the simulation starts running, this state is what is going to be executed first. It's always going to start from here. This is from where your logic is going to begin. And it basically identifies the starting state of the chart. So now the next thing that we're going to do is we're going to implement our transitions and we're going to connect the two states. And the way that you can do that is you can just drag from one end of this state to the other state. And similarly, again, from here, I'm just going to drag from this end and I'm going to connect it back here. So now that I've got my two transitions, there is a way for the robot to go from one state to another. I'm going to go ahead and I'm going to add some conditions. So I know that the robot is, when the robot starts moving forward, it's only going to turn right when the value from the distance sensor is going to be lesser than 1. So let's give it a, let's say sensor range, which is basically the value from the distance sensor, is lesser than 1 meter, it's going to turn right. And similarly here, the condition from turn right to move forward is going to be when the sensor range is greater than 1 meter, it's going to continue to move forward. And when you click on these transitions, you should be able to move these conditions around to make it look a little cleaner. So basically, sensor range is the input. It's coming from our distance sensor. So this is basically all the logic that we just wrote out. So basically, it's going to start from here. This is going to be our first state. The robot will start moving forward with these speeds, and it's going to continuously check. Now, if the sensor range or the distance from the distance sensor is less than 1 meter, it's going to turn right with these speeds. And when the distance to the wall is greater than 1 meter, it's going to move forward. So that's relatively simple logic. Now, you will notice that to your right, you will find something that's called the symbols pane that should have popped up If you don't have it, there's nothing to worry about. Just make sure you're under the simulation tab. And here you will find a section that's called Prepare, and it's got a drop down. Click on that, and under Configuration and Simulation, you should be able to find the symbols pane. So go ahead and click on that, and the same thing is going to pop up. It should already be open for you, but if you don't have it open, you can always find it here under the Simulation tab. So once you've got that, you will notice that everything that you have here are basically all the variables that you used in your chart. So the variables that you used in your chart was the left motor, right motor, and sensor range. And those are the three variables that you're going to be able to see in your symbols pane as well. And you'll see that there is a column here that's called type. So when you click on this type, you will be able to specify whether these variables are input data or if they are output data. So we know that sensor range is input data. So I'm going to go ahead and click on input data. And you will then see that the warning sign next to it goes away. So similarly, I'm going to do that with left motor as well. We know that left motor is output data. So I click output data and the warning sign goes away. Right motor, again, I click on type and then I say it's output data. And then you will see that you don't see any of those warning signs and all your variables have been resolved. So basically all that you've done is you've basically just set your input and output variables. So once you do that, you can either keep the symbols pane open or you can feel free to close it, whatever you want. And just like how you navigate through a lot of things in Simulink, the way to go back to your Simulink model is to use this tool strip and click on track wall _SF _start, or you can just click on this upward arrow right here and it's going to take you to this top model of yours. So once you come in here, you will notice that your input is sensor range and your output is left and right motor. It's all been specified. You can also feel free to change the name of this chart. You can call it, we're trying to track the wall, so let's call it track wall. You can do all of those same things that you do with any other block in Simulink. Now, once you've done that, go ahead and make your connections. So I'm going to connect the left motor, the right motor. My input is coming from the distance sensor. And once I have done that, I am going to go ahead and I'm just going to minimize this for a quick second. And I'm going to go ahead and hit the green run button. And I can see my robot basically tracking the wall. And I showed you this last week, but basically if you'd like to, you can just click on these signals. So you'll be able to see the value that's going from the distance sensor, and you'll be able to see the values that your left and your right motors are getting. So this is a very useful debugging feature, which is going to help you see what values are actually going into your motors and coming from your distance sensor. Now, the good thing here to see is if you double click on your state flow chart, when your simulation is running, you should be able to see the states transition. So you can see that the robot is moving forward, the move forward gets highlighted, or when it's turning right, turn right gets highlighted. So whatever is happening in your simulation gets highlighted here, and you can also see the transitions getting highlighted. So you can use this again as a great debugging feature to be able to see where if your logic is failing, you can see which part of it is not really working. So when you run your simulations, open out your state flow chart, to be able to see how it's doing. So you can do this to see which state is running, which transition when it's getting highlighted. And you can also go back to your top model, and you can also use these yellow boxes. And these yellow boxes will only pop up once your simulation is running. So once you run your simulation, you can just click on these signals. And if you want to take them out, if you just click on the signal, it's going to go away. And if you want them back, just click on that again and it'll pop up. So I'm going to go ahead and I'm going to stop the simulation. It's going to keep running until I stop it because the stop time is set to INF here. But basically, the takeaway from here is that you can also use a state flow chart to be able to track the walls. So we use a switch block, we just use a MATLAB function block, and this was another way using a state flow chart to be able to do the same thing, just to be able to track the wall. So there is a lot of flexibility in terms of whatever you are most comfortable with. You can feel free to use that method to program your robots, even for the competition. So that was a quick introduction into state flow. Does anyone have any questions before we move on to the next exercise? Okay, I don't see any questions, but if anything does come up, feel free to let me know. I'm going to go ahead, close this. And under this same unit, Intro to State Flow, you'll find that we've got another exercise. It's called Navigate Obstacle. So go ahead and open up the Navigate Obstacle _ start. And when you open this out, you'll find you've got the obstacle environment, you've got the left and right motor, and you've got your state flow chart. You can go into your state flow chart as well. You will see that it's basically got two states, but we don't have any transitions. So nothing is going to happen. If I just quickly run this, nothing is going to happen because we haven't written out made the transitions in the state flow chart. I'm just going to stop it. But basically just want to show you that this is what we're trying to do in this exercise. We're basically trying to navigate around this obstacle, and we're going to use a state flow chart that makes the robot move forward and then turn over a period of time to navigate this obstacle in the field. So something different that you see in this model is that you don't see your distance sensor. So basically that means that we have no source of input that's coming in, right? We don't have a distance sensor to tell the robot to sense the obstacle or a wall and then turn. So what we're going to be doing in this unit is we're going to be using something that's called as temporal logic. And what that basically means is that we tell the robot to move a certain distance with a certain speed for a certain amount of time. So we tell the robot to move forward for a certain amount of time. And then it's like telling the robot move forward for 5 seconds and then turn right for 5 seconds, right? So we're basically giving it the amount of time that it's supposed to turn for or move forward for. So that's basically what temporal logic is called. And that's what we're going to do with this exercise. So I'm going to go ahead and I'm going to double click on my state flow chart. And once I have my state flow chart, you've already got your two states, that is move forward and turn left. And now once you've got that, let's go ahead and edit these states and write out the logic. So it's going to start, the default transition is that move forward. So this is where the algorithm is going to start executing. So when the robot is moving forward, we want it to move forward with a speed of 100. So left and right motor, speed of 100. You can also feel free to resize it a bit if necessary. And then when the robot is turning left, I'm going to go ahead and I'm going to give it a left motor, a value of -50 because it's turning left. and right motor a value of 50. So this basically makes the robot turn left. Once that's done, the next thing that I've got to do is I've got to add my transition. So I'm going to go ahead and make a transition from move forward to turn left, and I'm going to add a condition. And like I said, we don't have anything coming in from the distance sensor. We don't have an input here. So we're going to use temporal logic, which is basically we tell the robot for how long to do a certain task. So I'm going to say after, let's say 8 seconds. So what this basically means is that the robot is going to move forward, and after 8 seconds, it's going to turn left. And then after turning left with this speed, I want it to again transition and then move forward. So I'm going to give it another condition, and I'm going to say after 4 seconds. So the robot is basically going to start with moving forward for 8 seconds. After that, it's going to turn left. It's going to turn left for 4 seconds, and then it's again going to move forward. And this is going to keep happening for the robot to be able to navigate that obstacle. Basically what I'm trying to show you here is that even if you don't have like a distance sensor available, you can still tell your robot for how long to move forward, or for how long to turn, or how long to reverse its direction, and so on. And to do that, you just basically use these after conditions. So I'm going to go back to my Simulink model. And in this specific model, which is navigate obstacle, I believe there's a glitch in the model. And so there's a quick change that you're going to have to do when you're trying it out. Just double click on the obstacle environment. And under robot settings, you will be able to find initial position, X and Y. So go ahead and change the value of X from a negative 1.2 to just 2 and hit OK. So again, real quick, double click on the obstacle environment. You will find a bunch of parameters. You will find robot settings. You will find initial position at the end. The X value was negative 1.2. Just go ahead and change that to 2 and hit OK. So now once you've done that, go ahead and hit the run button. And you'll see that the robot is now trying to navigate this obstacle. And again, you can see this side by side. You can see the different states, and even in your symbols pane, you should be able to see the values that the robot is taking. When it's turning, it's negative 50. When it's not turning and it's moving forward, it's 100. So this is going to keep happening, and I'm going to go ahead and I'm going to stop the simulation. But basically, this is how you can use temporal logic to be able to get your robot to do certain tasks. And in your Mechanics Explorer, like I mentioned before to you, you can go ahead and you can replay your simulation. You can also just rewind to the beginning. You can step forward once you're playing, or you can also step backward. The other thing that you can do here is that you will find that you have a slider here which says 1x. You can also feel free to change that up to see it go faster. So you can say 8x, or you can say 16x, and so on. So you can change the pacing over here, right here at the bottom. Now, the other thing that you can do here is in your Simulink model, under the Run button, you'll see that there is a drop down. So if you click on that, you'll see that you have an option called Simulation Pacing. So if you click on that, you can make the simulation run slower, or you can make the simulation run faster. So that brings us to the end of this unit, which was an introduction to state flow. So you learned how to use state flow. We also looked at some temporal logic when you don't have a distance sensor involved. So you learned how to implement states to control the robot behavior, implement time-based or temporal logic to automate robots, and how to speed up your simulations for faster troubleshooting. So you can just change the simulation pacing, and you should be able to speed it up or slow it down and help you troubleshoot. Does anyone have any questions related to this? Okay, so if you don't have any questions, I'm going to go ahead and I'm going to move on to the next exercise. So back here, we just finished Unit 7. So let's go to Unit 8, which is Maze Solving Robot. I'm going to double click on that. Again, you've got a PDF. Feel free to check that out. And I'm going to open out the maze robot _ start model. And this is going to be a little exciting. And the reason for that is if I just quickly run this, and I'm going to, it's not connected. But basically, what we're trying to do here is that you'll find that this environment is a little different. And we're basically going to try to get the robot to navigate all through this maze, right? It's going to start here, and we want it to go all through here and reach this endpoint over here. And if you just scroll into your robot, you will find that you have 3 distance sensors. So you've basically got one in the front, one on the left, and one on the right. Going to go ahead, close that out. And let's look at this again. So once we've got our, once you open out this model, maze robot _ start, we're generally used to using one distance sensor, but now we've got 3 distance sensors, one in the front, one in the left, and one in the right, is because we have to sense our obstacles. We have to sense the walls in front of us and to the right and to the left, and that these sensors are necessary to help us navigate the maze and to see which direction we need to move, right? So let's go ahead and double click on the state flow chart. And once you navigate and do the state flow chart, the next thing that we're going to do is let's go ahead and write out our logic. So we've got here move forward is our first state because that's where we've got our default transition. Let's go ahead and write out our code for that. It's very similar to what we've done before. So let's just type out left motor is equal to 100. Right motor is equal to 100 as well. So that is when the robot is moving forward. When the robot is turning left, I'm going to copy out those lines of code, but I'm going to make the left motor a -100. because it's turning left. And when the robot is turning right, I'm going to give it this value, and I'm going to give the right motor a value of -100 because it's turning right. Now, after that is done, the next thing that I'm going to do is I'm going to fill out my transitions. And for that, let's say that my robot begins to start moving forward. Now, when is my robot going to start turning left? My robot is only going to turn left when my front sensor has my front distance sensor is probably detecting a wall in front of it, and when the right sensor also has a wall. So that means I have a wall to the front and wall towards the right. So my only way to move is to move left. So I'm just going to say that when my front distance, which is the value from my front distance sensor, is less than, let's say, 0.5, and when my right distance, which is my distance from the right distance sensor, is less than 1. I want the robot to move forward. So I start with moving forward, and the only time that we will go to turn left is when there is a wall that is detected in the front by the front distance sensor. Let's give it a value of around 0.5 meters. And when there is a wall to the right of me, so my right sensor is also giving me a distance value which is less than 1 meter, I know that my only way left is to probably turn left. Now, similarly, let's write out the condition for turning right. It's going to be very similar. You will only turn right when there's an obstacle in front of you. So when my front distance is lesser than 0.5 meters and my left distance is lesser than 1, I'm going to turn right. Just make that lesser than 1, I'm going to turn right. Now, you can also, you've got your distance sensors involved here, and so you write out these conditions, but that doesn't mean that you can't use temporal logic. You can still use temporal logic. So you can say that you want the robot to only turn right for about, let's say, 2 seconds. So you can say after 2 seconds, you want the robot to move forward and transition to the next state. And similarly, you can do that here as well. You can say after 2 seconds, you can move these around. So now that we've got this, we've basically written out our logic, our symbols pane. We don't see any warning signs. Everything has already been resolved for us. And if you want to make your state flow chart or Simulink model fit in your screen, you can just always just type this, click on the space bar, and that's going to fit it on the screen for you. So this is our final logic. We start with moving forward, and the speed is 100. And then it's going to turn left when there is a wall in front and when there's a wall on the right. And it's going to turn left for about 2 seconds. And then it's going to turn right again when these conditions are met for 2 seconds. And then it's again going to come back to this state. Now, So this is just an example of how you can use, even though you've got input from your distance sensor, you can still also use temporal logic as a part of your algorithm. And but some things that you have to note is you're probably going to have to trial and test some things to see when you're, especially when you're trying to do your temporal logic, right? Because when the robot is turning with a speed of 100, I can say after 2 seconds. But if I say I want to turn right with a speed of 50 and negative 50, then this value is probably going to change from 2 to 4. So once you write out your logic, always run it, see how it works, and then move forward. So all your connections have been made for you. So let's go ahead and run this, and let's see if that works. I'm going to double click on my state flow chart. And I'm going to try to see if my robot is actually navigating the maze. So you can see the states getting highlighted based on what the robot is doing. The robot is moving forward right now. You'll be able to see the transitions getting highlighted too. Robot is almost there. It's been doing a pretty good job. And it's reached the end of the maze, and I'm going to just go ahead and stop it because it's going to keep running and going to keep navigating all the way back as well. So this was just how you could use temporal logic and use your state flow chart to be able to get your robot to do certain tasks. Do any of you have any questions? Okay, so I see a question that says, in the symbols pane, it is showing duplicate values for all of the inputs. For example, there are 2 front disk inputs. That's likely because you've made an error maybe in your spelling. So basically, if your L is capital in one and L is smaller case in the next time you write it, it's going to show duplicate values. So you have to make sure that it's all consistent. You don't have any spelling mistakes, and even your caps. So if you've got a capital L or a capital M somewhere, make sure that it's all the same. Because everything that pops up in the symbols pane is everything that pops up in that you write out in your state flow chart. So any of the variables that you write out here is going to pop up here. So if there are some duplicates, it's probably because you've made an error in writing it out the same way. Okay, so you don't think there are any spelling or capitalizing errors. Why don't you just, you should be able to click on it and delete it if you see that it's getting duplicated and if there are no errors. So feel free to do that and see if that works. So just right click and delete. And that should be able to work for you in that case. Try that out and then go ahead and hit run, and then your robot should be able to navigate the maze. But if you feel like you want to just cross-check, make sure you haven't made any errors. There's always a solution script that is available, so make sure you check that out as well. If any of you have any questions, feel free to put that in the chat. We can answer them. And for everybody else, if anybody doesn't have any questions, we can wrap up for today. So again, we're recording these sessions. We're going to be sending you a recording to this tomorrow. If you've got any questions, you can always reach out to us at roboticsarena@mathworks.com. Send us your questions and we will, if you're running into errors and stuff like that, we will help you fix that. If you've got any installation issues, make sure you contact technical support. And again, if you want to get full files, you can either get it from the Add-ons Explorer or you can just click on this link. And what that's going to do is it's going to open out a GitHub repository like this, where you can download all of that. So if you just click on File Exchange over here, you will be able to see that here there are some requirements. So it says it requires MATLAB, Simulink, Image Processing Toolbox, Navigation Toolbox, Robotics System Toolbox, Simscape, Multibody, and Stateflow. So you need to make sure that you have these things installed in order for your robotics playground to be functioning well. So sometimes if you get errors, it's most likely because you don't have these. And I can go ahead and I can put this in the chat right now so that you can verify if you have all of these. And one of the ways that you can do that is when you go to your MATLAB, just go ahead to your command window and type VER and hit enter. And you should be able to see everything that you have. So you can do that in your command window and look at if you've got all of those products. So you can check if you've got MATLAB, Simulink, if you've got the image processing toolbox, and so on. So if you don't have any of these, your robotics playground is not going to work. And if you see that you don't have one of those things, you can just always go to the add-ons tab here, click on Get Add-ons, and in the search bar, just type out whatever product you're looking for and get it installed. So that should help with your errors. And just a reminder, from your robotics playground, today we covered Unit 6 using MATLAB functions, Unit 7 Intro to Stateflow, and Unit 8, which is maze solving robot. We don't have any assignment for this week. That's probably because we want you to be able to just do all of the units, make sure you have a chance to look at the PDFs, try out the exercises, and make sure you familiarize yourself with the robotics playground. So in all of these sessions, starting from 1, 2, and today 3, all we've done is we've basically done simulations, right? We've basically made our robot do certain tasks to make sure that it works, and that's generally how you will get started. Even when you are programming your best robot, you likely want to get started with simulations. It's going to help you save time. It's going to help you make sure that your logic and your algorithm and everything works fine before you actually deploy it to your hardware. And for that reason, next week, we're not going to be doing too much of simulation. Instead, we're going to be doing hardware to wrap up this Simulink workshop series so that you guys have an idea of how to actually program your robot. So you start with simulation, and that is the basics. That's what we've covered until now. So make sure you look at all of the lessons, the units, familiarize yourself with that. And next week, we'll show you how you can deploy whatever you do in simulation, how you can put that into your. We've had 3 sessions before, and this is the last and final session of the series. And as always, so in our agenda for today, we're going to be looking at hardware. So we're going to be looking at the V.E.S.T companion app, and we'll be looking at the SimBot and how you can interact with your the sensors and the actuators of your robot. So let's switch over to MATLAB. And like I mentioned before, we've been using the robotics playground. We've been looking at the lessons, and we've been focusing on simulations. And which basically means that we looked at what is MATLAB, what is Simulink, what is Stateflow, and everything that we did was simulation based. And for B.E.S.T, you are going to have to be able to deploy all of these algorithms that you do in simulation, finally to your physical robot and to your hardware. So today we're just going to cover how you can get started with that. So the first thing that you'll need to do to be able to program your robots or your hardware specifically is in MATLAB under the Home tab, go to Add-ons. Most of you are probably familiar with this button. We also used it for the robotics playground. But we're going to go to Add-ons and say Get Add-ons. Let's give it a quick minute. And in the search bar, go ahead and type out V.E.X. and hit enter. And then you'll see a bunch of things come up. And the first one that you should probably see is called the V.E.X Companion app. So go ahead, click on the V.E.X Companion app and install that. Now, if you have, I've already installed it, so I can see that there is a green installed button here. But if you haven't, you should find a button here that will say install. So go ahead and install that. So that would be the V.E.X Companion app. And if you scroll down, you will also find the Simulink Coder Support Package for ARM Cortex-based V.E.X microcontroller. So these are the 2 things that you're going to have to install. So go ahead, click on the Simulink Support Package for ARM Cortex-based V.E.X microcontroller and hit install. So again, go to your Add-ons Explorer, type out V.E.X. Make sure you install the V.E.X Companion app and the support package for the ARM Cortex. And please make sure that you download the ARM Cortex and not the V.E.X EDR v5. They're both different, and it's easy to get confused, but B.E.S.T Robotics uses the Cortex, ARM Cortex, and the V.E.X Companion app is what you would need. So again, these are the only things that you need to be able to deploy to hardware. You can still do everything in simulation and do your algorithms and all of that without these 2. Now, some of the hubs are probably going to be using Gizmo as opposed to the V.E.X Cortex. We are currently working on providing support for the Gizmo board, and we will let you know as soon as we have that. But basically, the difference would be you would have to install a different kind of support package as opposed to VEX. It would be called something else. We don't know what it's going to be called yet because we're still working on it. But everything that I show you today, it's going to be very similar to how the new Gizmo blocks would probably look. The only things that would probably change is maybe like the range of values. The icons will probably look a little different, but everything else that I do today, like connecting and everything else, will be the same as it is for the Cortex. And since we don't have Cortex support yet, we're still working on it. I'm just going to show you how it works for VEX, for the VEX Cortex, and hopefully we should have support for Gizmo soon. So once you've installed that, this is for VEX Cortex, obviously. The next thing that you will do is once you install stuff from the VEX, from the Add-ons Explorer, you go to your Apps tab. And under the Apps tab, you should be able to find the apps that you install. So this is where you also found the Robotics Playground app, and similarly, you will also find the VEX Companion app. So if you go ahead and click on the VEX Companion app, this is what's going to come up. There are different tabs here. The first one is going to say VEX V5, and the second one is VEX Cortex. So make sure you click on VEX Cortex because that's what you use for B.E.S.T. And then you will find that you have a bunch of different buttons here. The first one is going to be New Cortex model. So if you just click on that, all that's going to do is it's going to open out a new Simulink model for you. It's basically just a canvas, a blank canvas, and the major difference that you will see here, as opposed to all the other models that we opened out in the last few sessions using the robotics playground, is that here you will find that we've got this tab which is called the hardware tab. So the hardware tab basically already has your hardware board that's been pre-populated there, and you'll find some different buttons. So you'll find the monitor and tune button, and you'll find the build, deploy, and start button. And this is equivalent to your run button in simulation. The build, deploy, and start is what you will click when you want to deploy your algorithm to your hardware. So the reason we ask you to stick to the VEX Companion app is because when you use these buttons, all of this comes already done for you, right? So your blank model will already have the hardware tab, your hardware board will already be selected, and so on. So it just makes it easier for you. And similarly, again, on the VEX Companion app itself, the second button is going to be called Open Cortex Library. So if I click on that, it's just going to open out a bunch of blocks. It's just like the Simulink library browser, but this is specifically with VEX paths. So it's just a good place for you to find everything that you will need. And if you click on actuators, you'll be able to find a bunch of actuators. You can feel free to just drag them, just like you've been doing it in simulation as well. It's all the same. So you can feel free to maybe drag a motor in, and then go back to the library. You can find a gamepad. You can find a gamepad button. There's your sensors here. Your ultrasonic sensor, digital input, analog input, and so on. There's LCDs, there's convenience libraries here. And what convenience libraries basically mean is that here under math library, you'll be able to find a bunch of these math operations. Let's maybe drag in the gain. And under utilities, you'll be able to find a bunch of things like state flow, switch, MATLAB function, a display, scope, and so on. So it's just basically all of the blocks that you found in your library browser. It's the same thing, but it's just basically been put together here so that it's easier for you to use. And these are the blocks that you should use for when you are doing your WEX Cortex, because these are the ones that actually work when you're trying to deploy to hardware. So this is the library browser again, and everything that you can do from this WEX Companion app. So you can open out your new Cortex model and you can find all the blocks that you need to be able to create your model. So the recommendation is to stay within the app. It just makes it easier for you and it's less work and less number of steps. So again, here, everything would pretty much be the same. You've got an input. This is just a quick example. You've got a gamepad but input over here. Let's just give it a gain, and then there's your DC motor. So in simulation, we used to press a green play button, which was called run. That's how your simulation is to run, and your robot used to do different things. Like in the last few sessions, it used to track the walls, it used to go around the obstacle, or it used to navigate the maze and so on. When it comes to hardware, under the hardware tab, what you're going to be using is you're going to be using this build, deploy, and start button. So when you click on that button, that is the button which is basically going to transfer the algorithms and all your Simulink models, and it's going to transfer it to your robot so that your robot does whatever you've designed it to do. So if I go ahead and if I just click on this, it's not going to work right now because I don't have any hardware connected. And also the way that you connected it is through a USB. So you connect your robot to your computer with a USB cable. If I just go ahead and I click on View Diagnostics, you'll see that I get an error over here, and it basically says that this may be because the WEX board is disconnected from your host computer. So when you hit this button, Build, Deploy, and Start, if there are any errors, MATLAB and Simulink are generally very good with telling you what the problem could be. But basically just hitting this button and making sure that the hardware is connected to your laptop is all you need to be able to transfer your algorithms that you design all the way to your robot. So this is how you get started with using the WEX Companion app. And there's the library. And let's go ahead and look at one of the examples. So I'm just going to open out this model here. It's basically an ultrasonic sensor. In one of the units in the robotics playground, when we were looking at simulation, we looked at the distance sensor. So let's just look at something very similar here. Here I have an ultrasonic sensor and I have a bunch of blocks. Now all of these blocks again are from the WEX Companion app. So if I open out my library, in my library here, under actuators, I'll be able to find my DC motor. That's how I got those two. And then I've got my sensor here. So again, within the library browser itself, you'll be able to find your ultrasonic sensor. I just dragged that and used that. Then we're using a subtract block, gain block, and so on. So all of those blocks, again, you'll be able to find right here under utilities. You should be able to find a few blocks, like you find your constant block, you find your variable input block. And if you go to math library, you'll be able to find your gain, your add. You'll be able to find your subtract block right here. and so on. So all of these blocks that I have here is from the Vex Companion app. It's from the library browser. It's just things that I've dragged and I've put together. And all that I'm trying to do here in this model is basically I want the robot when it's moving to stop when it's about 0.3 meters from an obstacle. So when there's an obstacle in front of the robot, when it's 0.3 meters away from that obstacle, you want the robot to stop. So here what I've got is I've got the ultrasonic sensor. So again, if you just double click on that, it's going to give you information of what it does. So it basically says it measures the distance to an object, and it also gives you the range. It says 0.02 to 2 meters. And then it gives you a description. And if you need any help with what's going on, always make sure you just click on this help button, which is available in each block. So we've got our ultrasonic sensor. And now once we've got that, we want to determine the distance from the obstacle that we want to stop. And we're going to call this the distance, the set point. So for that, we've got this variable input block that if I double click on that, it's you can consider it to be like a slider, and it's got a low value and it's got a high value, right? And for this variable block, I'm going to give the low value to be 0, and I'm going to give the high value to be 2. And the reason I'm using 0 and 2 is because that is the range of the distance sensor. And I want the robot to stop when it's 0.3 meters away from the obstacle. And so I'm going to set this set point to be 0.3 meters. So that is the variable input, and this is just a normal constant block with a constant value of 1. So now that I've determined the distance where I want the obstacle to, a distance from the obstacle where I want the robot to stop, which is 0.3 meters. The next thing that I need to do is I want to determine the distance between this set point and the sensor reading. And to do that, I'm going to use this block, which is the error block. And I've just named it error, but basically it's just a regular subtraction block. If I double click on that, you will see that the signs that I've used are positive and negative. So once you're done with that, so now I've determined the difference between the set point, which is coming from here, which is 0.3 meters, and my sensor reading. And the next thing that I'm going to do is I'm going to use this gain. So the gain is basically multiplied to this error to make it large enough to keep these motors moving. So again, if you double click on the DC motor, you'll be able to see that it says here that the input values range from negative 128 to positive 127. So those are the values. And so the gain is just used to multiply the error to make it large enough to actually work. We're scaling it because the input is likely going to be very small, so we want to just make sure that the motors can actually move. And since the motors and the robot are in opposing directions, we're going to have to reverse the signal of one of the motors. And to do this, I'm using another gain block with a gain of -1, which will reverse the direction of one of the motors. So this was basically the logic behind it. And again, the aim of this is to make sure that a robot stops when it's about 0.3 meters from an obstacle. So once I've got my model ready, the next thing that I'm obviously going to do is I'm going to hit build, deploy, and start. And when I do that, this algorithm gets transferred over to my hardware. Now, I obviously don't have hardware connected, but I'm going to show you a video of how this works. So I'm just going to go ahead and play that out. And you'll see that the robot is moving forward, and then it just stops when it is 0.3 meters away from this obstacle, which is this wooden block that you see right here. So let me just go ahead and play that again. The robot is moving forward, and then it will just stop when it's 0.3 meters away. So again, this is something that you can change. If you wanted to stop when it's 0.5 meters away, you can just change this 0.3 to 0.5 and it's going to do the same thing. And again, the low and the high values are based on this on the distance sensor. So I've put 0 to 2 because that is the range of this ultrasonic sensor. So when you double click on it, you'll be able to see that it's from 0.02 all the way to 2 meters. So that's the range that I have used. But all of these blocks are very similar to what you've done in simulation itself. You just have to likely change things like the DC motor and the ultrasonic sensor because and what I mean by that is basically use the blocks from the VEX Companion app because that's what's going to be compatible with your robot. So this was a quick example of how you can make your models and transfer them to your hardware. The next thing that we're going to look at is this button that's called Monitor and Tune. But before we do that, I wanted to check if anyone had any questions. So make sure you install the relevant app, which is the VEX Companion app, in this case for the VEX Cortex. Always recommended to use new Cortex model, use this to create your models and get your blocks from the Cortex library. And then it should make it much easier for you. You'll also see that the VEX Companion app has got a bunch of pre-populated examples here. I'm going to open some of these in a minute and show it to you. Basically, all of these examples are just good starting points, and I can show you how they are when it comes to programming your robot. Okay, so I don't see any questions. I'm just going to go ahead and I'm going to close this out. I'm going to close out this video as well. And the next thing that we're going to look at is we're going to look at that monitor and tune button that I showed you at the top. So here's what it is. So we were looking at the build, deploy, and start button until now. And that is the final button that you're going to actually be using. But a cool thing that Simulink has is this monitor and tune button. And this monitor and tune button is something that you will find under the hardware tab. So hardware tab, you'll be able to find monitor and tune, and you'll also be able to find build, deploy, and start. So talking about this monitor and tune, what is this monitor and tune? So it's basically a debugging feature that is available. And what it basically does is that it basically, when you use it, you can tune parameters while the model is running on the hardware in real time. So basically what happens is if you change any parameter values from within Simulink, those values are immediately communicated to your hardware. So it just helps you debug. So you can think of it as a communication process between Simulink and an external program. And the communication channel is obviously a USB connection, which allows you to transmit and receive data. So let's look at this example. And this is from an IR sensor counter example. And I'm going to open it out, the model, in a second. But basically, this is basically an IR sensor, which is something that you're probably going to be using when you're programming your robots. And one of the components here is a transmitter that will be transmitting an infrared beam. And then it will also have an infrared receiver. And the transmitter will basically have a beam projection area. And when this overlaps with the receiver field of view, you're going to get a detection. So I'm going to show you, I'm going to open up this model and show that to you real quick. So let's go to the VEX Companion app. And when you go to the VEX Companion app, I showed you that there was a bunch of pre-populated examples right here. So here you should be able to find something that's called the best IR sensor counter. So if you click on that and say open example, it's going to open out this example for you, which is what we just saw in the PPT. So basically here, it's going to tell you, it's going to give you a description at the top. It says it's an interactive Simulink model, counts the number of times the IR beam is broken between the two parts of the B.E.S.T robotics IR sensor. And again, all of these blocks are blocks that I got from the VEX Companion app. Let me show that to you real quick. So let's go to the VEX Companion app, going to the library. So this is the library here, and we've got display blocks, and here under utilities, you should be able to find the display block. So this is the display block that you can just drag that in and you can use it. These are the two blocks that we've used here. Again, going back to that library, we're using, if you go to sensors, we've used an IR sensor here. I've just renamed it, but it's basically a digital input block. So you can feel free to just drag that and get that into the canvas. And here we've got a counter subsystem. And again, all of those things have all come from the utilities and the math library. So this is a fairly simple model, right? So here, all you're trying to do is you can use this model to make sure if your IR sensor is functioning correctly. So once you've got your IR sensor, you're going to basically be gathering data from the sensor using this digital input block. So if you double click on this block, it's going to tell you that it's going to read a digital input port on the VEX ARM Cortex microcontroller. The output of this block is either 0 or it's going to be 1. And then we've got this counter subsystem. So if you double click on that, you'll see that there's a bunch of blocks right there. So in this counter subsystem, all that we're trying to do is we're basically trying to detect the increase. So we're basically trying to detect the number of times an obstacle comes in front of the IR sensor. And we're just going to count that here. So that is the counter, and then we've got a display block here, which is going to display a numeric value. And here as well, we've got a display block. So here we're just trying to read the data from the sensor using this digital input block. And here, this is basically going to count the number of times an obstacle comes in front of the sensor. So this is going to make a little bit more sense when I play out the video. So when the LED on the receiver is on, there's successful detection. Otherwise, there is no detection. So over here, basically, you'll see that both your display blocks are now at 0. Every time you bring an obstacle in front, you see these values changing. And this it changes from 0 to 1. 0 is when there is a detection and 1 when there is no detection. And here you can see at the bottom that it counts the number of times the obstacle comes in front. So let's just look at it again. So if you look at this video right now, first time the obstacle is coming in contact in front of the IR sensor. Second time, value keeps increasing in the counter here. The third time, this value keeps increasing. Go ahead, play that one more time so it's easier for everyone to see. When the obstacle is in front, you see the change. It changes value from 0 to 1. And here, and so that's shown in the first display block. And in the second display block, it's basically just counting the number of times the obstacle is brought in front of the IR sensor. that is a quick example of that, of how you can make sure different components are working, right? So most likely when you are trying to program your robots, you're going to have to make sure that different parts of your robot are working. So you have to first make sure that your IR sensor is working properly. So you can probably use this model to make sure that is working. Another important thing to note is that when you see the description in some of these models, you will see that it says run this model in external mode. And external mode is basically monitor and tune. It was called external mode a couple of releases ago, and now the name has been changed to monitor and tune. So it's basically the same thing. But basically, you can use these models and you can use monitor and tune to be able to test some of these components and to debug some parts of your robot. So basically, from this example, you just saw that you can monitor the detections from an IR sensor in real time. So every single time you're doing something to the robot or you're trying to test a certain component in real time, you will be able to see things in Simulink at the same time. So it's simultaneous. Let's look at another example here real quick. So here is tuning actuator commands using Simulink. So again, we're going to be using monitor and tune, which is under the hardware tab. This model is fairly simple. All that we have here is we've got a constant block and I've connected it to a motor. And I've done this 3 times. So basically it's the right motor, left motor, and then for the arm. So let's look at a quick video on how this works. So if you look at this closely, I'm basically running this model, this Simulink model in monitor and tune, and you can see how it shows up in real time at the same. So I'm just changing my constant value from 0. I'm just going to go ahead and I'm going to change it to 20, and you will see immediately here that your right motors begin, your right wheels begin to move. And similarly, if you do that for your left motor, you will see that your left wheels begin to rotate as well. So basically with monitor and tune, anything that you change in your Simulink model will immediately be reflected in the hardware. So again here, if you go to the left motor, you change it to 0, your left wheels will stop rotating. And similarly, if you do that to your right wheels, you'll see that will also stop rotating. You can also change it to -20, which basically means that it's going to rotate in the opposite direction. But basically, this is how it is, how monitor and tune is very useful to help you debug. So this is how you can make sure that different parts of your robot, different components are all working fine. So we just saw that for the right motor and for the left motor. And now we also have a motor for the arm. So basically this arm, we're going to try to raise this arm. And to do that, we're just going to go ahead and we're going to change the constant value for the arm. So if I double click on that constant there, and I'm going to change it to 20, and you'll see that the arm just dipped down for a bit. But if I want to raise it, then I'm obviously going to give it a value of -20. And you'll see that it tried to raise up, but it was struggling. So let's give it a little bit more power. So I'm going to just change that from a -20 to a -25 and hit OK. And then now you'll see that the arm raises with a lot more ease. And again, you can feel free to change that to 0 as well. So this is how you can check on different parts of your robot. So we're going to get into creating interactive dashboards for your robots. Does anyone have any questions on monitor and tune? We're still going to be looking at it, but does anyone have any questions until now? Okay, if you have any questions, please feel free to put in the chat. We can answer them. Yes, all you need to be able to use the monitor and tune is the USB cable. You just have to make sure that your hardware is connected to your computer so that it reflects in real time. So we're going to be looking at something that's called as a SimBot. Now, the SimBot is basically a robot that was designed for teaching B.E.S.T workshops. It's got all the same components that you use for the competition. And in this case, in this example, it is the B.E.S.T ARM Cortex that is being used, but it's got all the same things, like it's got one servo motor that serves as the gripper. It's got 3 DC motors connected to the left wheel, the right wheel, and the arm that can lift up objects. And it's got a series of sensors like contact switches, potentiometers, and infrared sensor. So it's basically got all the same things as your B.E.S.T kit. So here what we're going to do is we're going to look at this example, which is running it with monitor and tune. So we're going to be looking at some dashboard, SimBot dashboard example, and how you can test different parts of your robot using monitor and tune. So this is what the model is going to look like, and I'm going to open that out in Simulink in just a minute. But you can basically use this dashboard to make sure that your sensors and your actuators are all working, and you can do that using monitor and tune. So what you see here at the bottom is what we just saw. The IR sensor with the counter and the 2 displays. We just saw that example right now, so you can make sure you can try that out to see if that part is working. Then here you will see that we used some potentiometers, and we've got some limit switches, and they all have displays connected to it. And the reason why we have displays is because we want to see what values it's giving. So we're looking at the output to make sure that everything is working fine. So when you look at this potentiometer here, you'll be able to see that you see some values here, which says 3,404 and 4,095. So let's just open up the model to see what that is. So again, under the B.E.S.T Companion app, in these pre-populated examples, you should be able to find the B.E.S.T SimBot dashboard. So if I just go ahead and I open that out. And at any time, if you want to be able to fit your model on the screen, just go ahead and hit spacebar, and that'll kind of like just fit the whole thing for you. But basically, the whole idea of this dashboard, like I mentioned, is for you to test your different components. So this is the part of the IR sensor that we just looked at. You can make sure that your IR sensor is working fine. You can count the number of times that the obstacle comes in front of the sensor. And here we've got your potentiometers that you use. It's available in your kits. So again, if you double click on this block, like if you double click any other block, it's going to give you a description, and it says it reads the analog input port. And then here it says the output of this block represents the voltage given out by an analog sensor, where a value of 0 reflects an input voltage of nearly 0 volt, and a value of 4095 reflects an input voltage of nearly 5 volts. So basically, the value is going to be between 0 and 5 volts. And it's basically, it says the value, it can go up to around 4095. So 4095 reflects 5 volts. So those values that you saw in the presentation right here, this 3404 and 4095, that's how you're getting those values, right? So the fact that you're getting these values, which basically means that it is working fine, it is within the range. So in this case here, it is the value is 5 volt. Similarly here for limit switch, you can see that the displays are outputting values of 0 here, and it's giving a value of 1 over here. So if you go to your limit switch, you double click on that, you will see that it is the digital input block. And in the input block, obviously the output of this block is either going to be 0 or it's going to be 1. And that's how you get those values of 0 and 1 in these display blocks. Now, once we've been able to check that all of our sensors work fine, the next thing that we're going to look at is we're going to look at our actuators. Now, coming to our actuators, we have already looked at some of them before. So I just showed you how you can make sure that your motors are working fine, your left motor, your right motor, and your arm motor. And here you've got your gripper servo. So if you double click on that, again, it's going to tell you that your input values range from negative 128 to 127. So you know that is your range, and you can easily make sure that it works fine. And again, here we've got a variable input block, and the values have been negative 127 to 127. And all of that is coming from here, right? We know that the gripper servo, the range is from negative 128 to positive 127. And so when I look at my variable input, my range, my low and high values are also going to be selected based on that. So again, you can change up these values, see if your gripper is working, just like how we checked in the previous example. If your left motor and your right motor, and if your arm is working, you can also make sure that your servo is also working in the same way. And you can record the maximum and minimum values for your servo. So basically, you can use that variable input and to derive the maximum and input values. So you can see that the minimum value looks like this and the maximum value looks like this. So you can see basically the positions that are safe to operate. So having something like a dashboard like this is pretty useful because it helps you just make sure everything is working fine. And to do all of this, you will use monitor and tune. And again, in a lot of these examples, we do have a bunch of links. We sometimes have some PDFs and documentation, which gives you a good explanation of what this model does. And in some cases, we also have a bunch of videos that are available. So if you can watch the video also in some cases to get a better understanding of what the model is. Okay, I don't seem to be seeing any questions, so I'm going to keep moving ahead. But last week we looked at something that is called as state flow, and we use our state flow charts to program our robot. And so here, let's open out one of these examples. I'm going to open out B.E.S.T IR sensor line follower 1. So if I just open that example. it's going to give me this model. Again, it gives you a quick description of what this model is. You'll see that you'll be able to have more information about the algorithm that is used in this video. So make sure for explanations and to understand the algorithm and stuff like that, you check out this video if you're not already familiar with these algorithms. So here, basically, it's just a line follower. All of these blocks are again coming from the VEX Companion app. So if you go to the VEX Companion app and you go to the library, you'll be able to find the DC motor under actuators. And then the other thing that we have there is the IR sensor. That's under sensors. You'll be able to find the digital input block. Then if you go to utilities, you should be able to find state flow and also arcade. You'll be able to find the arcade module as well under utilities. But basically, that's how you get all of the blocks, all from the VEX Companion app. And here we're using a state flow chart. So again, in the state flow chart, if you double click on that, it's basically got two states, go left and go right. So here what we're trying to do is the input is coming from the digital input block. We're gathering data from this sensor, and then we process the data using this state flow chart. And then we use an arcade block to set the speeds of the left and the right motors over here. And here it's mentioned here that for this, we're using the on and off controller. That's the algorithm that we're using. And there is a video explaining what this algorithm is. So make sure you check that out if you don't know what that is. And I have a quick video on that. So let's go ahead, open that out. So here there's a quick video of the robot moving. So basically the robot turns right and the robot turns left. And we're basically following the line from the right edge. So again, all of these models are just available for you to get started with. So if you go to these pre-populated examples, there are a bunch of different models that have already been created for you. You can use these as a starting point to be able to create more advanced models and to do more with your robots. But this is definitely a good resource for you to get started. So we have a bunch of examples, like we've also got a line follower 3, which basically has got 3 sensors. So if you look at that, it's got a left IR sensor, it's got a center IR sensor, and it's got a right IR sensor. And for this example, it's using a weight-based algorithm. Again, for more information on the algorithm to understand what the logic is, make sure you watch these videos. But basically, wanted to show you how you can get started. You know about how to use simulations. Once you're done with simulations, the next step is to deploy it to your hardware. And for those of you who are using the VEX Cortex, make sure you install the VEX Companion app and use that, use the blocks from the VEX Companion app, especially the sensors and the motors. Those are the only things that matter. All of these things, like your state flow algorithms, can be the same as what you did in simulation, right? All of that doesn't change. The only things that you have to be careful about is choosing the right blocks for your inputs and for your outputs mainly. And you can use monitor and tune to make sure different parts of it are working fine to be able to debug. And then finally, when you're ready to deploy everything and make your robot run and deploy all of these algorithms to your hardware, make sure you hit the build, deploy, and the start button. If you quickly go to your web browser and say B.E.S.T Robotics MathWorks, there should be a web page that pops up. This is the same web page that you use to request your license as well. I can quickly put this in the chat. If that's easier, this is where you request your software. But there are a bunch of resources that you can use. We've got a bunch of videos as well, which should help you get started. But an important resource to use is the B.E.S.T Robotics Getting Started Guide. So if you go to this guide, you will be able to see everything that we've got. So we've got a bunch of examples here. What we've covered in these sessions is the robotics playground. We've also got some of the mobile robotics tutorials here, like the line following robots, obstacle detection, and stuff like that. So you can feel free to check that out as well. There's got videos over there. And we've got a bunch of other additional resources too. So you can feel free to check these out. And if you've got any questions, you can reach out to us at roboticsarena@mathworks.com. So now this Getting Started guide is very specific for B.E.S.T Robotics, and that's really all that you need. But just in general, if any of you need robotics resources, we've got another link right on top there, which is basically available as beginner, intermediate, and advanced. So there are different levels, and you can choose what you would like to do. So if you want to start with beginner, there's robot modeling and simulation. It's different kinds of content. We've got a video, we've got blogs. For intermediate, we've got different other resources that are available. And this is a lot more advanced. And these are other resources that are available for any of you who are robotics enthusiasts and you just want to be able to learn a lot more what you can do with MATLAB and Simulink. Here is a quick resource, right? So here it's way more advanced. Like we've got like reinforcement learning for walking robots and stuff like that. So if you're interested, you can feel free to check out this resource as well. It's been linked for you on this page. But for B.E.S.T, for the purposes of B.E.S.T, all you need is the B.E.S.T Robotics Getting Started guide. So you can click on that, and it's got links to all of the resources that you need to prepare for the competition. So that was a quick introduction to hardware and how you can get started with deploying your algorithms to hardware. That's really all that we had for today. We're going to be sending you a recording to all of this. In the meantime, if you've got any questions, please feel free to reach out to us at roboticsarena@mathworks.com. If you've got any questions, feel free to put in the chat and I can address it. If you think of questions later on, you can send us an email. But yep, that's all we had for today. I hope this was helpful. Thanks, everyone.
Thank you, Tanya.
Thank you. So in the B.E.S.T Companion app, if you don't see any Cortex examples, that's because you haven't installed the B.E.S.T the support package. So if you go to the Home tab, you go to Add-ons, say Get Add-ons. You have to type out B.E.S.T. So you have to install two things. The first thing is the B.E.S.T Companion app. And then you have to also install the Simulink Coder Support package for ARM Cortex-based VEX microcontroller. So once you do that, you will be able to see the examples pre-populated. If you don't have that, you will see that it's going to give you this button that says Install Support. So if you don't have it installed, it's going to prompt you to install it like this. Both of them show as installed. Okay, so if they both show as installed, go to your homepage, go to add-ons. You have an option that says Manage Add-ons. Click on that, and then you can again say here VEX. And here you've got 3 buttons here. You can feel free to just uninstall it and install it again to make sure that it all works fine. But once you've installed some stuff from the Add-ons Explorer, you can go to Manage Add-ons and you can edit some stuff here. So if you want to uninstall it, you can feel free to uninstall it here. Just try uninstalling it and install it again, and that should work. Maybe there was some kind of error. And if that doesn't work, feel free to send us an email and we can help you out.